Hello everyone. So, hello again. Azure AI Connect 2026. A bit of a rough start. We had a little small issue, but we have our guest with us. So, Tiago is ready as usual. I'm going to add Tiago to the stage right now. So, welcome, Tiago. I'm so happy to see you, my friend. How are you doing?
Yeah, I'm doing fine. And what about you? All good with you?
Yes, I was in Denmark, the Experts Live sessions, and a lot of trips around because we have a small daughter and I have to take her to the grandma. And now I'm also traveling again tomorrow, so it's a bit of a mess. And in the middle of it, Azure AI Connect. Thank you for being with us. Thiago is a well-known professional, so many years in IT and in cloud, mostly Azure. He's also a very well-respected MCT, and we are very lucky to have you with us, Tiago. Thank you for being with us. So, the future of AI, quantum copilots, and the next era of innovation. I think we're going to see a very interesting session. Uh, I have added your screen on the session, so the stage is yours, my friend. Thank you for joining us.
No, okay. Thank you so much. And it's like quite an honor to be the first session, okay, in all of this, okay. So yeah, so the session is about the future, okay, or at least, well, what we can kind of try, to predict, okay, because it's never easy, of course, as you guys can imagine, to predict stuff within tech. And we have very famous visionaries that are also famous for actually not guessing at all what was going to be the future. Like an 8K per byte computer will be enough for everyone, and things like that. So I don't want to be one of those, definitely not. So what I'm seeing here is a little bit you know my thoughts about it. Okay, let's just think about it as my personal thoughts about it. It's not a prediction, okay, but just wanted to share a little bit, because artificial intelligence, as we all know, it's evolving faster than ever. And in the next decade, there are a lot of promises, breakthroughs that will just redefine the way we work, the way we create, the way we secure systems, okay. And we can take a deep look at the future of AI, also by explosion, by looking at and exploring some other emerging trends like quantum computing, okay, like autonomous copilots, like multimodal AI, and a bunch of other stuff that I don't want to ruin the session for us. Okay, so just talking a little bit about myself. My name is Tiago. I mainly work as a cloud and an AI architect and advisor, which is kind of a fancy way to say, hey, I help organizations, companies around the world to move into the cloud, and also working with bleeding edge technology, which now corresponds a lot of using AI in their workloads, okay, and try to make a good use of AI in their workloads, like when it actually makes sense, and kind of not doing the hey, let's AI everything, okay, because honestly, that's definitely not something that I personally believe, okay. Then we also talk about I'm a trainer. I also do some content creation. That was actually what I was doing before I joined this call. I was actually just creating here some demos for a course that I'm actually recording right now. And I'm also a public speaker, so it's normal to find me in this kind of conferences, also in person, all around the world. And I've been working, with tech since ever, Azure since 2010, when it wasn't cool. Okay. And I'm also an Azure MVP certified trainer, and I have a bunch of certifications around this. And I love to travel, by the way. So I've been in 78 different countries around the world. And, hopefully, if everything goes well, and, if our international leaders, they behave quite nicely, I'll be doing 80, okay, in a few months. Okay, hopefully everything will be fine. Okay, so and I'm also from Lisbon, Portugal. That's where I'm based on. Okay, so let's get started and let's talk about the future of AI, quantum copilots, and the next era of innovation. And what I want to do is mainly explore some of the groundbreaking technologies, okay, that are shaping and will shape tomorrow's world, okay? So with this, let's just talk a little bit about it, like a small introduction here, and what we're going to talk about. And like I said, the session is titled The Future of AI, Quantum Copilots and the Next Era of Innovation. And the idea is to explore this rapidly evolved landscape that we have with AI. And also all the implications that we're going to have with this in the next decade or so, okay? So we're going to talk about what is emerging AI technologies right now. We're going to talk about some of the security challenges that we have with the rising and the adoption of new AI technologies, also the strategic implications that we have with this. So if you're attending today or watching the recording of this and you say, hey, look, you know, I'm not a super 100% tech person, but I have strategic responsibilities on, what technologies we should go for. This is your session too, okay? So don't run away. And then we're also going to talk about some of the visionary insights, okay? So some of the visionary scenarios that we have that might be actually quite cool. So agenda for this session includes what is AI today, current state of AI, where are we standing right now? Quantum power AI, what is this? Let's just talk about this concept that we have in here. We're also talk about autonomous copilots, multimodal AI, the next generation security challenges, and I still have some stuff around strategic implications that we have for enterprises, okay, and how to prepare, for all of this. For sure, I want you to have something that, bam, you can just take today out of this small session that we have here, because this is actually a big topic, and we could be here probably the whole day, talking about this. So in terms of emerging AI technologies, we talk about quantum, of course. That's actually something that I'm personally, studying right now. So I'm actually right now not studying the practical part of this. It's actually the theoretical part of quantum, and it has been quite a challenge. Because to be totally honest, gets me back kind of in my university years, where we had to study a lot of mathematical stuff, and this involves a lot of math. Okay, but actually it's quite cool to understand all the I don't want to say bits and bytes, because here is different, all the quantums. Okay, because it's actually quite interesting, so that you can then understand the technology and then go to more practical, part of all of this. Okay, so like I said, there's a lot of implications when it comes to this, and a lot of breakthroughs that we can do, especially in terms of optimization of applications. Okay, but also in cryptography, also in things like, for example, machine learning. Okay, and with generative AI, we take how much time to train new models, like ages, right? It takes weeks, months, even in some of the of the larger language models, and again with very capable hardware nowadays. But all that hardware, will be junk totally if and when we unlock quantum. Okay, and quantum starts to become, I don't want to say mainstream, okay, but even before mainstream, okay, but something that enterprise and maybe the big players can actually use, and in a very practical way, because that will be unlocking a huge gate of possibilities, because of the amount of capacity that we're going to have with that. But look, it's not just unlocking the hardware, it's also unlocking the software. It's also taking those models and running them in a quantum way, because you cannot just unplug them from the way that they're running right now, plug them in quantum and they were going to work. Okay, no, definitely not. There's a lot of adaptations that we need to do. There's a lot of rewrites that we need to do, but that's something that, hey, definitely can be done. Okay, and when we do this, there's unlocking a lot of possibilities. And of course, organizations and big companies are actually investing tons of effort, money, okay, too, in this kind of stuff. Okay, because like I said, quantum mechanics offers a different way to process information. Okay, and a different way that will exponential speed up, okay, certain type of problems, not all problems, okay, but certain type of problems. Like for example, in the context of AI, model training, data analysis, and solve all those complex problems that now take tons of time in classic computing. So this will be something that, hey, can actually be quite cool. But not only that, okay. Also, for example, research. Nowadays, if you work, for example, for the pharmaceutical industry, when they are developing new drugs, there's a lot of also computational needs for them, to model something, to try something. Again, with quantum, they can just do that. Like today, you're in Word, then you just do file save PDF, okay? And the time that it takes, it can be something that you might have a researcher. Hey, let me just try this. He fills in kind of a form in the screen. You just press OK. Something that today might take days, weeks, it will just take seconds. Okay. So that will be quite achievable, because imagine the number of possibilities, okay, that today it's just not feasible, and they need to do some choices. With quantum, they don't need to do choices. They can just say, hey, just run every possibility with every possibility, and then bam, okay, just give me results, okay. So that will be actually something quite cool, that we're going to be able, okay, to do with this kind of stuff, okay. So what we see here is, quantum computing advantages. We kind of already covered that. Enhancing capabilities of AI uh, in model training, but also there's also other industry impact adoption. I talked about pharmaceutical companies. You can also talk about financial services. We can talk about logistics that has also crazy, complex problems. I'm actually into very much into logistics right now, because one of my customers, I'm actually actively right now working, okay, exactly on this problem, okay. um so there's a lot, that we have to do with this. Future prospects, that we have with this, there's this practical quantum AI applications, okay, that are evolving right now. So there's a lot going on this space, okay. Talking about, for example, I'm very much connected with Microsoft, okay, and Microsoft Quantum, okay, has a lot of advantages, okay, because it leverages all the principles that we have with quantum mechanics, okay, and gives us, okay, actually this, okay, gives us a lot of tools that we have, so that we can actually start today, working and learning a little bit on this. And I'll get to that in just a moment, okay. So enhance AI algorithms. So what we have is integration of quantum algorithms, okay, so that this can actually today accelerate, okay, AI training models, and we can actually start using, okay, this like today, okay. It's not what you expect when you heard quantum a few years ago. It's very like super early days for the technology, so the performance is not yet there unlocked, okay, but something that we can start learning this, so that when they unlock this, boom, we are ready, okay. So tools, what kind of tools do we have? So there's the Azure Quantum Development Kit, or KDQA, and it's basically an open source, okay, toolkit that we have. It supports a new language that's called Quay Sharp, Key Sharp. Okay, it's basically, as the name says, okay, Sharp. It's a little bit connected with C Sharp, okay, but different. But it has some similarity. So if you're into .NET, you can easily learn this. And today with tools like, for example, GitHub Copilot and things like this, look, you can start running some programs in this language quite quickly. Okay, there's also a lot of VS Code extensions. Okay, for the Azure Quantum Development Kit. Again, for VS Code extensions helps you. Okay, developing things with this. Okay, there's more. There is the quantum katas and sample projects. Okay, that I can also show you that, and there is actually a lot of simple projects that you have that are awesome to learn Quay Sharp, okay, and Azure Quantum. There's also Microsoft Learn, quantum computing modules today, free, self-paced. You can just go there and you can start actually learn quantum. Again, early days, it's a little bit fundamental what is there, but hey, it's actually quite interesting. And there's actually the Azure Quantum community, okay, where we have, basically on Stack Overflow, also on GitHub, that we can actually have a chat, okay, with the community about our challenges and, questions if you need the help on something, etc. You can actually use that to, basically improve your skills on this, okay? So if we want to basically just to see a little bit this, let me just change here the screen's a little bit here, sorry about that. So so you should be see my front screen right now here. And for example, if we go to github.com, okay, Microsoft, and then it's K2K, okay, like this. I think it's like this. There you go. So this here, okay, and let me try to check something in here, okay? Okay, there you go. So yeah, okay. So just making sure that you're seeing the same screen as I was. So this is the the SDK for Quantum link. It's easy, okay, but still, let me see. Okay, I think I can't. Yeah, I can't share this with you guys, but you guys see it here. Okay, I'll zoom in. Okay, so it's github.com Microsoft, and then just the name of the SDK. Okay, and you have, and if you go to the the README Markdown, there's a lot of information in here. By the way, how to get started with this, how to build a playground, okay, for this, how to debug, etc. So you have lots and lots of great information in here. But look, this is definitely not the only thing that we have. We also have on Microsoft Learn, and for this, I actually need to grab the link from here because it's just easier. Okay, there you go. So we also have this, which is basically some documentation. Okay, and I can just zoom on this here, and you can see it's basically learn the Microsoft.com Azure Quantum, and then KDK main overview. Okay, and in here, look again, there's a lot of information about how to get started with this, about building simulations. Okay, that we can do with this. So there's a lot of great stuff again, in here that you can just have some fun and just see how this works. Okay, and actually running this on your machine today with emulators, or even run this in actual quantum hardware. Okay, and we're going to get to that in just a moment. Okay, yeah, sorry, I still want to show you two more things. Okay, so there's actually also some learn modules, okay, for you to learn a little bit more about the topic. One is this, it's kind of getting started, okay, with Azure Quantum, and we have here 6, okay, different modules that you can go through. They're always being up to date. Okay, I actually did them all, and now they're saying that there's new things in here. Okay, well, because when they update things, you no longer have the check mark here. But look, you have lots of great information here. I actually did them all. Okay, maybe with not this account. Yeah, maybe not. Okay, and again, lots of cool information. For this, I will just zoom in this, and then you can pause, the recording if you wish. Okay, and you can just see it and check it there. Okay, so great stuff. Like I was saying, lots of great resources that look, you can just start today. Okay, it's not something that, oh yeah, in the future we are going to be able to do this and that. No, it's actually stuff, okay, that today you are ready and you can just fire up and just use this stuff. Okay, so there you go. So more stuff that we have, with this. Let me actually do another demo here, okay, which is using actually Azure Quantum, and let's see how we can actually deploy something like this. Okay, so for that, let me just zoom in here. Okay, there you go. So we actually have quantum workspaces in Azure, and if we would like to create one, it's pretty simple. In which subscription you want to create this, you need to have your subscription unlocked for this, which doesn't come by default. So most probably you're going to need to request that first, before you do this. And there's just this option. Okay, quick create. Okay, it actually gives you like an emulator. It's actually not the real thing. Okay, it's an emulator, but it's free. Okay, and it's actually great for you to learn. Okay, if you actually want to run stuff, you need to go for a paid hardware access. Okay, and this is something that, yeah, most likely you're going to need request access for that. Okay, but hey, so if I go for this, I can create here a new resource group. I'll just say Azure Quantum. I'll just accept the normal one, and I'll just say AZ Tiago Quantum. Okay, and then again, you can just select here the storage account is managed. Okay, and the providers that are going to be in this workspace are going to be those two, Quantum and Rigited Quantum. Okay, so this is actually something that in the paid version we actually can have more. Okay, and look, you just need to create this. This is as is. Okay, it actually doesn't take that much time. Okay, now to create my access to this, but we're not going to wait. Okay, but basically this is it, and this will give you access, okay, to a quantum workspace, like we call it, where you can actually just start running things on this. Okay, so with this, okay, not there, come on, sorry, but my mouse, I think I need a new mouse because my mouse started like this afternoon. The click doesn't work quite well. I have to actually force a lot to do the left click. Okay, so there you go. So now let's talk about multimodal AI. Okay, so that was quantum. Okay, we could of course talk about a lot about quantum in here, but let's just move on to multimodal AI. And multimodal AI can integrate, like we say, very types of data types. Okay, it could include text, vision. We can have sensor inputs into what we call unified models. Okay, and we can actually understand and generate really complex, outputs or inputs if we want to understand those inputs. Okay, of course, as you imagine, this capability that we are creating enables a more natural and intuitive interaction that we can have between a human and a machine. Okay, and let's never forget, it's a machine. Okay, it's not someone else on the other side. Even though lots and lots of models they pass the Turing test, still a machine. Okay, for example, in healthcare, using that as an example, multimodal AI, they can analyze, for example, medical images. They can analyze patient records, voice inputs, and then assist a doctor, okay, or a patient, okay, in a diagnosis of what is wrong, with that patient. In manufacturing, it can monitor equipment through, imagine, visual and also sensor data and predict failures. Hey, there's a great possibility that this thing here will fail, okay, and will fail in X number of hours. So before it actually fails, maybe do some maintenance on this, okay? So this is the kind of things, that, hey, very, very cool things that we can actually do with this. In creative industries, we can actually use this to generate multimedia content, okay? And we can actually combine, a lot of different other data that we have into, create this. When I say, creative content, I'm saying a painting, I'm saying, an image, I'm saying music, video, etc. Even though this is, just me, Thiago, I'm actually not a big fan of using AI, okay, to like generating music, for example, okay, or generating a painting, okay. Yeah, we can do it. Actually, some of the stuff is actually quite cool and quite good, but I really think that there's some stuff that we should leave to humans, okay? So, not a big fan, of actually having this kind of stuff, okay, available through an AI. Okay, yeah, we can have it. Okay, sure, why not? But just be careful with that and how we use it. In the Microsoft world, we have Microsoft Foundry. Okay, and Microsoft Foundry is what we call the unified AI development platform. In just one, okay, single integrated environment, we can build, we can deploy, we can manage our AI solutions. Okay, we have lots of models. We can bring models. We can build agents. Okay, we can build tools and capabilities to those agents, and then, hey, the agent, you're going to use that model over there, and you can create multimodal architectures. Okay, we have security, we have identity, we have management, we have observability, we have the possibility to add our own data into this, okay, and connect this with our own data, connect this with our own APIs, and then not just through an MCP server, but actually, to a direct API call if needed. Okay, so stuff like this can actually be done. Oh, and we can actually use Azure services, GitHub, Visual Studio, Copilot Studio. Okay, all this together in this environment. If we look, kind of in a fancy diagram, this is what you're going to get. Okay, which is, we have Foundry, and then, we have our models that come available for this. We can have agents, okay? We can have AI search that can actually connect to our own data and actually help us, vectorizing this data, so that we can actually use it in a augmented, to augment those models with our own data. So there's actually a lot of cool things that, hey, we can actually do with this. Okay, again, observability, security, identity management, and then a lot of clients that we can use for this. We can use an SDK, we can use GitHub to develop this. Visual Studio, Visual Studio Code, whatever. And we can then connect this, through Azure, because this runs on Azure, to our own, cloud data, to our own cloud workloads that we already have there. But also using Azure Arc and Foundry Local, we can actually, connect this to the edge. This edge could be, for example, some of our servers, some of our on-prem, databases that we might still have. So sure thing, that's actually something that we can definitely do. Okay. And for example, if we want to look at, this, and look, this, as you can imagine, this session is not about Foundry, it's not about creating things, but very, very quickly, okay, if I just want to show this and how we can create this. So we have Microsoft Foundry here, okay? And I can go to Foundry, and I can just create, okay, basically a new Foundry workspace in here. And, after, hey, I have this, okay, great things, I can just connect to it, okay? And I can access the Foundry portal. And this is where, kind of the magic, okay, about this will happen, okay? And for example, it's in here that I can go to the model catalog, okay? And you can see that, we have loads of different models that they're loading. I don't know why they're taking so much time. There you go. So they're actually loading in here, okay? And I can just go and I can just use, okay, some of those models. And actually, this is not, the one that I wanted to load. I wanted to load this one here, okay? There you go. So if I go to models, okay, you can actually see here, okay, there you go, a bunch of different models, okay? I cannot actually also come in here, okay? And for example, if we go on the bottom in here, models and endpoints under my assets, okay? I can actually come in here and I can actually deploy, okay, an existing model, okay? I can go for a base model, for example, and under this base model, I can just go in here and can just check, all my models that I have here available. There's actually way more than this, okay? But this is limited, just to the ones that we have here, okay? And I can just come in here and just, add a bunch, okay, a bunch more into this, and I can just use one of those, okay? Like for example, I can go for Sora. Sora is for, video generation. I can just say, hey, confirm. There is, depending on the model, the very different types of deployment types. This has to do a lot of the capacity that you need, okay? And actually the latency that you need for this, the speed that you need. It's a big conversation. I'm going to have it today, okay? Number of, requests that you can do for this, the resource group location. Of course, we can customize, all of this and, just manage this as we would. If I go, for example, for a more, let's just say, GPT-5.2 chat, okay? It's a more common model, okay? So there you go. You can see that I actually only have global standards available for me. Okay, there are more, okay? That's actually just the ones that I have for me. And there's actually this tokens per minute, okay? And you can actually go up to 5 million, okay? And, just drill down this a little bit. So there's different options for different models. That's what I wanted, to basically to tell you, okay? You need to be careful, by the way, okay? Because this is actually something that I'm facing a lot at customers right now, which is it's actually very easy to build a POC. Not going to lie you, okay? Everyone can do an AI POC. Okay, you learn how this works. If you're a developer, you can just come in here, build a small POC, connects with this. This is connecting through an API. There's an SDK for this, like I showed you. Look, it's super easy to build a POC, like a proof of concept, okay? So for everyone that don't know what POC stands for, okay? So it's very easy to do that. The challenge with this, it's in getting proper responses for this, properly applying and integrating this in current applications, and then scaling this. Okay? Scaling this is actually one of the big challenges that we currently have. Because, for example, I use a lot a framework, what's called the Microsoft Agent Framework. And with the agent framework, what I do is, and one of the advantage of that is that easily, okay, and I'm like doing this with my fingers, okay, you can unplug a model and plug another one. Because, for example, in this here, I don't know if you can, the name of this is GPT-3.5 Turbo. It's actually a very old, you know, project that I have this for training and for, you know, just trying and having some fun with this. And I actually created that. This was actually calling a model called GPT-3.5. Or 3.5 Turbo to be more precise. What happens is 3.5 Turbo is not supported by Foundry anymore because from time to time that happens. You know, oh, this model, you know, it's too old. We don't want to support this anymore. Bye bye. Okay. And so you're like, oh, okay. So what about now, right? So the thing is, and what happens is actually now this is actually pointing to this model. And you might say, oh, yeah, so they did this for you, right? Yeah, they did. Okay. This is, like I say, you know, it's a demo project just for having some fun, training, you know, showing off the technology. It's not a big deal, okay? What's the big deal of this? Is that the prompting that I was using, imagine in a real world project to prompt GPT-3.5 Turbo is not actually the same way as it is for 4.1 Mini. I get different kinds of results, better, worse. That depends on a lot of different things, okay? But, you know, it's not just unplugging a model and plugging a new one, okay? Like sometimes the marketing brochure tell us, okay? In the SDK, yeah, there's this, but there's still some tuning up to do, okay, in the way that we're interacting with this, the kind of answers that we want to get. So there's a lot, you know, to this. But there's more, okay? So let me now, you know, show you this here again. And for example, in here, we're talking about this customization journey. Because like I told you before, look, it's not just about having, you know, the right model and hey, we're good. No, it's about, you know, having this user input, for example, that we have here in an application. And this user input that I have here is, hey, I'm painting my living room wall. What should I buy? And imagine we have this in our e-commerce web store that we sell. We're a company that sells, you know, home improvement stuff like some construction material, you know, paint, you know, some DIY stuff, you know, gear so that people can do their own home improvement stuff. Okay, so I start with doing some prompt engineering to the prompt that my user will do. Okay, because users in a website, they're not going to bother to do very good prompts. I need to tune them up like a lot. I tune and style this. I might create some example responses to this. I might map some of the intents that this user had. Okay. I might still do resource augmented generation. So maybe, you know, having this also with my own data, AKA in our case, maybe the products that we sell and their capabilities. Okay. So there's inventory retrieval. There's some personalization that we need to do. There's some query extraction that needs to be done with this, okay? We might even do a process that's called model adaptation, which is we might even would like to fine tune an existing model and then use that fine tuned model so that our application actually calls the fine tuned model and not the full large language model we just RAG, okay? But we're going to cover that just in the next slide. And then with this, we can get fast and accurate response, also using less cost, because cost is actually a big deal in all of this. Talking about fine tuning, okay? So with fine tuning, one of the cool things, that we actually have in here is that there's always this fine tuning versus RAG approach, okay? So RAG is going to learn something new, okay? Fine tuning, you're going to do something in a different way. So because fine tuning, you're just adding more ways of how to work out the answer, but you're not teaching the model some new data. Okay, that's not fine tuning. Okay, that will be RAG. Sometimes you actually would like to do both, still possible. That's called hybrid. You do fine tuning plus, okay, plus RAG. Okay, so that will be something that sure thing, that's what we can have for this. Fine tuning will be stuff like save tokens, adapt the model to reflect the way that you talk, okay, the tone and the style that you do. For example, there are companies that they have this very modern and to the ground nature of their customer service. They don't treat you on the third person. They are super direct with you. They don't need to be, super polite. No, that's their approach, is to be, to the target 101. That's what their customers are expecting. You can't have a model, like a generic model, to be super polite, because that's not the tone, get it, that their company uses in their approach. So sure thing, that's the stuff that we fine tune, okay? So we use fine tune to improve quality, and we might want to do domain specific optimizations, task specific optimizations to reduce token consumptions, okay? So that, hey, look, you don't need to look for this kind of stuff because it actually doesn't matter. And we can also have smaller models and then fine tune them and get way faster responses. Okay, so that's just one of the things that I wanted to cover. Then, what time is it? Oh, still have some 10 minutes. Okay. So then one of the other things that I also would like to talk about is agents. Okay, and we are in the agentic AI era, and more we're going to use a lot of agents. Okay. And look, there's also this multi-agent approach, okay, that we have. And if you look at this, okay, I actually created this slide here, right? We talk about single agent. And if we have like a single agent, look, we have a prompt and there is a planning, okay? There is probably, some understanding on what you want to have. There's a task that actually might, actually execute some stuff, okay, call an API, whatever, and then get a response. And then there's this replan. And then, we can iterate here until we can get you like a response, for example. So for example, I actually have, some agents running, like loads of them, to help me, managing my business, managing, all my deliveries, all my work, all my social networks, and etc. And this is one of the things that that I do is, for example, I actually have one which is to manage air travel for me, and actually finds, okay, I just tell him, look, I need to be here this day from this day. I would like to arrive at around this time at my destination, and I would like to leave around this because I need to be at home at around this time. This is all I tell him, okay? And in the background, is actually going to try to find, the best flights for me. Also because he has a lot of, memory, that's how we call it, about my preferences when it comes to flights, okay? Like airliners that I like to travel, the seat that I would like to take, look, a bunch of stuff. And I actually have the agent figuring it out, all that. He shows me a possibility, shows me a cost, okay? And basically, I just tell him, yeah, okay, you can go ahead and book that. And he actually does, and then he books that stuff for me. Okay. So this is the, really cool, because imagine in a very large corporation, usually we have a full department just to do this kind of stuff, correct? And most of the times, to be totally honest, I used to work in a very large company. Every time I needed to book a flight, I actually needed to send an email. Was some years ago, okay? So that helps too, okay? Don't feel it was very very old style, because this was actually some more than 10 years ago. Nowadays most companies, they have like a platform, right, where you go and you just choose, oh, I want this, but you still need to find it and look for it. And you know it's much easier if you could just have this conversation, or you can even automate this in a way that when you add something to your agenda. I don't have this is my dream, okay? If I add something to my agenda, it will already start looking for the flights, and then even in a last scenario possible, book it automatically, and I don't even have to know anything. It will just figure it out, the best flights, etc. For me. There's also this multi-agent pattern, okay, and sometimes not a single agent can do it all, okay. So we can grab lots of value through a team of experts, okay. And this is what we can get with, okay, multi-agents. We have an agent here for inventory tracking, another agent with an MCP connector with logic apps, another compatibility agent, another search agent. And look, we can have different kinds of agents that each one of them, will figure it out its own thing, and will have those capabilities. And then we can do some multi-agent orchestration, okay? And we can actually use the agent framework, okay? That's an SDK that we have to actually do this. Because here, we're actually talking about AutoGen and semantic kernel. I still would like to, I'm not taking this out of here, and we can actually create workable orchestrations, but there's this new experience called agent framework that combines, okay, AutoGen with semantic kernel, okay, in just one single framework. And then we can have, this kind of workflows like, hey, finish this, then pass to the next agent, then to the next agent. Or, we have other approaches where we can end off, we can do group chat. Look, there's a bunch of stuff. Again, we're not talking about this. I just have this last, demo that I just want to show you, okay, how easy it is and where you can actually do this. So under the Foundry, portal, you have this bit here that talks about, agents, and that's where you need to do this. By the way, if you want to do fine tuning, you can actually do it also in here, okay? And it's pretty much, at least a very basic fine tuning. There's actually some learn modules that teach you how to do that. So here, I can just say, hey, let me use this model in here that I have here, and now let me create, an agent, okay, for this, okay. You have your agent in here. Then you can give instructions to your agent. You can put a description. All those are pretty important, okay? A description about your agent. And then we can have knowledge. And under knowledge, see, as you can actually see in here, I can ground this with the internet. I can ground this, okay, with SharePoint data that, look, you might have somewhere, okay, in your M365 infrastructure. You can add local files. You can ground this with stuff from Azure AI Search. So there's a lot of, possibilities that we have with this. Okay. So there you go. And then you can connect other agents. That's for having multi-agent approaches. This will be the orchestrating agent. And now you can say, hey, and I'll connect with that agent and with that agent. So there's always one, okay, that is that's going to act as the orchestrator. Okay. So to close up what we have here, okay, security, okay, in the era of AI. Look, there's a lot of new threats that are coming because of those AI models. And even yesterday, there was an SVE, okay, around Anthropic, okay, and because there's like a way. It has nothing to do with now what's happening in the U.S. with Anthropic, with the U.S. government. Anthropic, it's something else, okay, that they found out with some of their models. There's also the quantum computing risks, okay, because like imagine what it is having quantum that in just a few seconds I can try to crack an encryption key that nowadays takes, I don't know, 100,000 years to crack using a brute force algorithm. But with quantum, I can just do this in a few minutes, let's just say, okay? That's actually, quite a big challenge. And of course, there's going to be the need to have quantum resistant cryptographic solutions. Okay, we'll figure it out. There's also collaborative security solutions. Okay, so there's already AI that needs to and then with cybersecurity experts to actually build all those resilient defenses that we need. Strategic implications. Okay, like I said, I was promising this. So what we have here is a little bit about automation that we need to enhance operations. We're doing this. Intelligent decision making, having AI powered systems that can actually do decision making. We need to be careful with this, as you can imagine, because you need to have really big trust in your system that it was trained with very valuable data. Okay, and that means that definitely you can trust in the output, because if it was trained with not so good quality data, the output will be exactly the same thing with not so good quality. Okay, so we need to be careful with this. And also, organizations, they need to assess and address gaps in skills, because people don't know what AI is. Believe me when I say this. When I go to companies and I talk with C-level people, I talk with a lot of people in the company, they sometimes think it's a wonderful thing that just magically works. Others have a totally misunderstanding of the power and the actual capabilities of AI today. Okay, there's all this that. There's also a big infrastructure gap, because as you all know, probably, we don't have enough compute, we don't have enough data centers, we don't have enough power capability, like electrical power, to power all the hardware that we want or we should have right now. And there's also governance, okay, so that we can actually have a successful AI adoption, okay? And there's this ethical and strategical use of AI that, we have lots of AI, ethical use, good use of AI, okay? As a company, this is something that I always telling my customers, you should group together, as a company and define, what is an ethical approach for you to use. So what you can and you cannot do. It's not because you have a law. It's because it's ethical for you as an organization. This is where we want to go. This is where we want to, and we create those guardrails, okay? So that guides you into your AI, approach that you're going to have for your company, okay? And last slide, I promise, okay? Organizational readiness, okay? Assess your AI maturity that you have. Check. Invest in innovation culture, okay? So it's not just having an AI project or an AI team like I'm seeing now, like we had with cloud, where people just create, a cloud success team here, or now they do an AI success team. No, it's much more than this, okay? So there you go, okay? And we can skip the others for time, for time concerns here. So, key takeaways from this: AI is evolving quite quickly. It's promising everything, okay? We might not deliver everything, and we need to be aware of that. There's a lot of emerging AI technologies, quantum, autonomous co-pilots and agents, multimodal systems. And this will definitely redefine the way that today we work. There's a lot of challenges with some, professions. Like if you're like an Uber driver, okay, or white collar, jobs. I don't believe that everyone is going to be impacted and everyone will lose their jobs like we hear sometimes in social media. I truly don't believe that. Okay, we're still pretty far from something like that. It's not like some people say in 18 months, is like the other day I read about it. All white collar jobs are gone. I'm like, okay, that's just not going to happen. Okay, some will be affected, definitely, loads of them, but not all. Okay, there's also the strategic preparations, or as an organization, invest in new technology because you can't stay behind. The performance difference will be so much, you're going to be bankrupt. Your customers will not use you anymore. They're going to use other organizations. Okay, training and actually find good uses where AI can actually make the difference. Okay. And again, not AI everything, please. Okay. So thank you so much. Okay. Hope you enjoyed, this small session about, the power of AI and some of the capabilities that we're going to have with quantum. I hope that you enjoyed. And for me, at least, it was a pleasure. Okay. To be here. Okay.
Thank you, Tiago. Amazing presentation. I really enjoyed your approach. And to tell you the truth, I'm really on board with your idea of not everything is about AI, and we should
Yeah.
keep creativity on arts and human-oriented stuff to humans. I totally agree with that. AI is very good at coding and doing things like that, but to a limit. So yes, I totally agree. I cannot see any actual questions in the chat, so would like to thank you and release you to your day. It's been an honor to have you with us again, and I hope we will meet in person sometime. You
Yeah.
are all around the world, my friend, and I really appreciate you coming here.
Okay. Thank you
Have,
so much. See you. Bye
have a
bye.
great one. Bye bye. Bye bye. Yes, quite an amazing presentation, I can say, by Tiago. A lot of stuff to ingest, right? And people that have the experience, people that have the expertise are already grounded, and they can present to us some balanced opinions about the emerging technologies. I really like this quote. It's not everything about AI, and I try also to implement it into my own way of doing things. You can evaluate sessions, Tiago's session, if you want, using this QR code. I hope you enjoyed it. We're going to have a small break, and hopefully, our next speaker will be on board. I cannot see the actual presenter here, but yeah, hopefully, he will be with us for the next session. So, allow me to play a small video in loop. Thank you everyone for being with us today. First day of Azure AI Connect 2026, and this is a little bit more compact session than the previous year, where we have almost 50 speakers. It's almost undoable with 50 speakers. I really appreciate you guys coming and enjoying our sessions. Let's have a small break, and I think our speaker is already here. Our speaker. So yes, we have Ashish with us for the next session, and I can see that also Emiliano is with us, but Emiliano is for the next hour. I hope that is not confusing, guys. And Ashish is our next speaker at 6:30. Let me bring Ashish on the stage, and I will let him introduce himself. Hello, my friend. I hope I'm pronouncing your name correctly. Is it Ashish?
Yes,
Hi.
and thank you for having me on board. And it's great to be here and share my knowledge with everyone.
That's great. We are really honored to have you with us. Thank you for
Hmm.
joining our session. I hope everything is all right with you and you can
Yeah,
go on with your presentation. You can bring your screen on your presentation on the screen, and I will add it right now if you want to.
hmm. Sure, sure. I'll just do that.
Amazing.
Um,
So Ashish is going to talk about replacing human departments with AI swarms while humanizing the process. Our
yeah,
speakers are really into keeping the human factor deeply engraved into the solutions, and I really like it. So Assis also has a similar approach by keeping humans within the process. But there is also another keyword, AI swarms, which I'm really interested to hear and see. So I'm going to add your screen here. And yes, the stage is yours, my friend. Thank you so much for joining. Ashish
perfect.
Paparia.
Perfect. So today we'll be talking about how we can replace entire human departments with AI swarms. But before that, we would need to talk about uh, can AI replace our jobs, or is AI there for us where humans are not? Or if I'm able to do something, will AI be able to do it better than me or even at par with me? So, yes, we'll be talking a lot about humans, the human departments, AI swarms, and etc. But who am I and why am I the person who will be speaking on this? So, I am Ashish, I'm an AI consultant, AI generalist, and I've been running a agency called Coso.ai where I automate uh, the the almost everything that human does. So basically, we build custom AI. We build custom AI products for the companies. We build custom AI automations for everyone. I teach AI, and besides that, I'm also a founder of Fido.com and around 18 other startup or 18 other micro SaaS. Besides that, I'm also a part-time domainer where I buy and sell .ai domains. So yep, I am deeply into the AI arena, and I've been in the AI arena since 2019 when GPT-2 was launched. So yes, I know what I'll be speaking about and I know what I'm talking about right now. So, but why do we want to talk about it? Like, just because, if we go and test it out, you can't even tell the difference between what is AI, what is human anymore. Like, for example, if you start the game and we just think if it's written by AI, if this is human, this is not, we can make the guesses, but we can't be really sure of what's AI, what's not. And usually we get the average result to be 5 out of 10. And if you know about the Turing test, it's when you can't differentiate AI with human. Turing test is when we get to a point where we can't decide whether this thing is AI or whether this thing is human. And trust me, AI has already passed the Turing test, especially in sound. There was music, there was a song, "Walk My Walk," which topped the Spotify charts, and people didn't even know that was created by Suno, which is an audio generator, which is an AI audio generator. And if AI has already surpassed humans in the creative arena, trust me, that is something that we should talk about. Then that is something that we need to discuss a lot more about. Then, but at the same time, we haven't talked about AI swarms till now because we need to talk about what makes up that AI swarm. OpenAI in the year 2024, 2023-24 released an OpenAI's 5-level AGI scale, where it said that it'll take us 5 steps to reach AGI. AGI is where the where it expands to artificial general intelligence, and it's where AI does almost anything human can, even think, come up with novel ideas, or be better than humans at almost every economical and the creative aspect of it. So in 2023 there were things like chat gpt that talks with human conversational AI. Then if you're seeing the benchmarks, models, LLM models started uh, winning Olympiads, solving PhD level problems. For example, Kimi 2.5 thinking was recently marketed as the one which solved PhD level problems, and then came AI agents. For example, OpenClaw. Uh, even I was talking to one of my OpenClaw on my Telegram right now, agents which are capable of taking actions. So these agents are connected to tools, have their mind, have a goal, and they um, take actions on user behalf. But what AI cannot do right now is AI cannot think of a new innovation, of something. AI cannot create something novel because it is designed to be a predictive model, not a usual, what do we call it, the normal human like model that has conscience. So once we cross that barrier we are doomed. But again, we it will take a lot of years, because again, chat gpt as we know it runs on a prediction model. It predicts the next token, predicts the next text. So yep, we are here and we are good to go for now. So we are still at the top of the food chain. We can still order our AI agent to talk to another AI agent, to talk to another AI agent to get the work done. And that is where swarms come in. But how does agentic AI work? What exactly is agentic AI? So, agentic AI is just like human. I'm thirsty while I'm speaking. So, what I'll do is I'll just pick up my water bottle, I'll drink some water, and then I'll think, okay, I guess I didn't quench my thirst enough. Let's drink it again. And that's how I proceed, and that's how AI agent works. For example, I am an AI agent. I have a tool which is a water bottle. I have a memory, and I have a goal. Memory that if I drink water from this particular bottle, I'll quench my thirst. The goal is to quench my thirst. Then I take an action. I'll open up the cap. I'll drink the water. I'll just observe my environment. If everything, if I have completed the goal, if I've reached the goal, and then if everything works out well, the goal is completed. If not, I'll repeat it again. So that's how AI agent works. It's just like human. It's as human as possible, because humans work in a similar way. For example, if my lighting is low, I'll just turn on the lighting. Like for example, this is the lighting that I'll turn on. Again, goal, memory, tool, observation. So if we uh, start with how everything works, is we have automation tools which started with if this and that. For example, if I reach home, turn on my Bluetooth. If I um do something, make this happen. AI workflows, on the other hand, add an AI mind in between. And when I say AI mind, it would be, let's say, if I reach home, and if I open Zoom, like my any of the XYZ application, order something for me. So basically we are adding in the AI workflow, we just add an AI mind in between. AI agents, on the other hand, are digital teammates who take decision on your hand, who um like who think on your think for you, who who think according to yourself, who take decision for yourself. So AI agents are autonomous agents. They are not a part of the workflow. They are autonomous agents. For example, OpenClaw that's working right now, it's an AI agent. one of my OpenClaw agent, what it does is it monitors my Gmail account. It sees if I have a new negotiation that's happening. It negotiates with the client, and then it even close the deal. So that's an AI agent for you. Now, AI, I'll be showing a lot of N10 workflows. I hope you know what an N10 workflow is, because again, it's easy to understand it visually rather than just seeing my chats with my OpenClaw agent. Again, so when I send a chat, AI agent will think. AI agent will connect to the tools. For example, Google, it'll search the internet for something, and then will do something, and then it will give up a result. For example, I created an entire uh, Red Bull ad for me. This was an agentic workflow with an AI brain in it. But there are more to it. For example, if you know this particular Langflow tool, this is how where we can even add rag to it, graph rag to it, add memory to it, search what we had, and we can connect a lot more tools and make it a really good fancy depending on the problem that we have. AI agentic AI workflows can be as um, what do we call it? They can be as detailed as possible depending on what sort of work you would want it to do. But let's consider it to be similar to solving a puzzle. We start with something, then we connect with something, then for example, how do I reach from A to B? For example, I'll have to take a bike, I'll have to ride a bike, I'll have to take a route. So that's how AI workflows are usually. And trust me, this is something called system architecture, because as long as you know how you would be able to do that job in the most human way possible, you would be able to make an AI do the job for you. Then, once you're good with it, you can build a fully agentic workflow. For example, like I have my subscription MCP, like I have my subscription Gmail, where if someone receives my newsletter email and the person replies to the same newsletter uh, email, my AI agent replies to it, right? And then they have a conversation, and it can go long for as long as 15 messages, and the person won't even know that it's me. Well, it's not me. It's my AI agent replying to them. So again, system architecture. If this happens, AI agent take. You have the brain, you have the tools, you have the memory. Do whatever I asked you to do. Act like me, do like me, or something like that. So that's uh, how you incorporate AI agents in your daily life, in your workflows. For example, I replaced my uh, like I had an employee in the creator's office who used to reply to my newsletter emails, and now AI does the job for me. So yes, this was the first employee I had to shift to another department, or I have to downsize because AI was doing his job. But these single agent were performing single tasks. For example, replying to an email is a single task. I gave it an instruction, I gave it a tool, but at the end of the day, it was just a single task. AI swarms is when an AI agent talks to another AI agent, and which might talk to another AI agent, and a lot of AI agent talk to each other, work with each other to accomplish one particular goal. They coordinate, they communicate, they share signals, and they all of them come together to solve one particular task. And we can simplify it as well. For example, I have this AI swarm where I receive messages on my Telegram. I receive uh, for example, I have joined a lot of Telegram groups which send me updates about AI. So I've created this AI agent, the first AI agent that collects all the messages and adds that to Google Sheet. Another AI agent would take the message, would check subreddits for AI updates. Another AI agent would check Hacker News for AI updates, and will add that to Google Sheet. Then what we are going to do is we are going to the another AI agent would take over, would read what's there on the Google Sheet, and then it would write newsletter for me. For example, we already have data, right? Or it'll write short videos or reel scripts for me, TikTok scripts for me. And that's how AI swarms who have one common database work with each other. And it's not just that, there are a lot of other AI swarms that I'll be showing or I might be talking about right now. But this was just one example, the simplest example in my department, which actually replaced my entire research and content writing team. But how can you build the same? See, you need to learn meta prompting. Meta prompting is when you teach AI model to prompt for another AI model. For example, if I teach ChatGPT, if I add a prompt to ChatGPT that you are a prompt generator or you are a manager and you'll have to handle an employee, so this particular model has to prompt this another model. That's what's meta prompting is. So again, you would need to learn meta prompting first before you even um, think of moving ahead with working with agents, because agents is good, you just give one prompt, but when you're working with agent swarms, there'll be an orchestrator, there'll be a manager, there'll be an employee. So for example, and once you learn the meta prompting, you would need to learn system architecture as well, how to get from A to B, what all route you would take, or you would need to understand how to do the things. For example, this is how it looks in action. For example, if you see at the back, uh, I created a system architecture of get the search the internet, write introduction, search the internet, create a code, search the internet, write the section, bring it all together, post it to WordPress. You can just go and check a website called generatestory.io. It has over 120 generators that generate part of stories. What this particular um, what the workflow does is it writes the introduction, it creates generators, it writes all of the XYZ, uh, the blog post around it, and then it posts to WordPress. So this was one particular meta prompting oriented workflow that I just showed, but it's not for anything. It's not for Langflow, Creo, or any other platform that you have. You would need to uh, you can add system architecture to any of the particular um, product that you're building. For example, this was for one of my clients back in 2023 when they Jasper or Copy AI was at their peak. But the problem with Jasper was it could not research the internet while it was writing, and there were a lot of hallucinations. So that's where we created a system architecture where we found the initial research triggered, and whenever someone typed something, we researched well before we type anything else. So this was one of the tools that we created. And if you can see, web complete actually searched for something over the web while creating it. Again, system architecture was simple, requirements could result in better clients. That's what I'm trying to say. So again, so if you can see, AI started writing again, but this was back in 2023 when uh, things were not as simple as they today are. People are not even reading anymore today. But to remove the human part, we need to orchestrate. Orchestration is when a AI manager talks to an AI employee, when there is an orchestrator involved, when there is a leader in the agentic swarm. And this is where things get really interesting. When you add a leader, you offload your responsibility of guardrails as well. The leader will handle the guardrails, the employee will handle the hard skills, and you're good to go. So, for example, this is a content writer swarm, or not a swarm, a workflow that I created where we can call it a swarm, where different AI agents do different tasks for stuff. For example, the first AI agent researches the internet. The second AI agent builds the outline for the entire article. The third AI agent, which is the manager, his work is to make AI employee write the article. He has the guardrails, he has everything. So what he does is he um, messages, talks to the AI writer, and then AI writer write the article. Then the manager checks if it has written according to the guardrails or not. If yes, it updates the Google Docs, and then when it is done, it sends me an email. Okay, so we are done with the article. Again, full-fledged uh, email agentic orchestration. That's again, the it was one of the most simple orchestrations that I've did. We usually, and this was just N10. N10 is just to show you how things are done. You can build complex orchestration, and you can automate almost every task of your particular department. But know that that orchestration runs on a 90-10 principle. 90% of the work will be done by AI, 10% would be done by you, because human in the loop is really important. AI cannot invent, AI cannot think like human right now. So yeah, you would need to add something to it. For example, this VS Swarm, just like I said, my AI handles the entire email negotiations for me. But at the end of the day, I was the one who set guardrails. I was the one which gave it more information about what to send, what to do, what not to do. So I am the boss. I will be the boss till the end. But again, if you are working as an employee, trust me, you are going to be replaced soon. I guess it's time that you need to start working with AI swarms. And to start with it, this is you would need to start master. You would need to master prompting. You would need to master meta prompting, design architecture. You would need to solve puzzles, because to get to A to B, to understand system architecture, you will need to solve puzzles. And once it is all done, integrate human intervention. Because again, how would you know if AI is doing the right job or not? I guess yes, build an MVP first. Think like this influencer marketing swarm that I built. This was for one of the companies that we built. This influencer marketing swarm, what it did was it transcribed all the reels of a particular creator, made sense of it, created a guide, and then for this particular company, told like for this influencer, is really good fit based on the contextual analytics. It's fit for this particular brand. How we performed this was again uh, system architecture. We had to find out how do we transcribe, how do we make sense of it, which AI model is good for what. Then the AI models talk to each other. One AI model just talked about uh, what topics are working well, what hooks are working well. One AI model actually just focused on much on what sort of scripts performed well or something like that. Then we created an entire um, product for that. So yes, code, build, and then think of selling. But start with building and start with learning new stuff. Don't ask what AI can do. Ask yourself what I can make AI do now, because again, it is already better than you in hard skills. We can't compete with AI right now. I guess that's it. This was my take on AI swarms. You can follow me on these channels, or if you still have questions, you can just join any of my WhatsApp group. Uh, it's not I won't be selling you any courses. I won't be selling you anything. I just would love to talk about what's going on in the AI world. So yep, let's continue talking, and that's my side of the story.
That was really interesting, Ashish. Thank you so much for being so detailed on your solutioning and your approach. I really like your
Mm-hmm,
presentation. I don't see any questions right now for from our speakers.
mm-hmm.
So again, thank you so much for being with us today. That was really interesting. I will need to see it again to tell you the truth. And I can see that you're using quite some tools. Have you been also using the N8N? Are you
So
are you
yep, I
familiar with
just
that tool?
Yes, I just showed a few of the swarms using Anytin because Anytin is the easiest to understand. But yes, I have been using a lot of agentic tools. I've been using Langflow, LangChain. I've been using OpenClaw for now. For example, OpenClaw is the hype right now, and it can do a lot of stuff. So, agentic AI, on the other, like we have also deployed our own frameworks for a lot of companies. Uh, a few of them to handle their supply chain management, a few of them because again different companies have different requirements. So yes, we incorporate a lot of tools. We love when AI think like humans
Yeah,
and
yeah.
talk like humans.
Yeah, yeah, yeah. Amazing. So big thanks to Ashish for being with us today. We're going to proceed with a small break, and our next speaker is already with us. So without any hesitation, bye bye, my friend. See you
Surely,
soon.
surely, thank you.
Thank you so much. Great. Yeah, we are moving quite fast, and I really like that. So before Emiliano comes into the stage, let me play a small break, and we will be right back with you. So, yes, day one Azure AI Connect 2026. Thank you everyone for being here with us today. We have started our sessions and we are already in our third speaker, Emiliano Mondesdeca. I think I pronounced it correctly, but he will correct me soon. Emiliano is a Microsoft MVP in developer technologies, and he will present a session supercharging level 3 support with AI, Azure Functions and OpenAI in action. So we're going into the serverless part of Azure. I really love it, and I'm going to add Emiliano on the stage right now so he can tell us more about the solution. Hello, my friend. How are you today?
Hello, hello. How are you?
Thank you for joining us, and I have to tell it's an honor to have you with us. It's the first time I think we meet online,
Yeah.
and again, thank you so much for delivering your session. So, what is your session about? I can see Azure Functions and OpenAI in action. Can you tell us a few
Uh,
words?
yeah. Yeah. So, well, first of all, thanks for you to for doing this. It's an honor to be here. So, if it weren't for you, we will not be here. So, first, thanks to you. Yeah. Regarding the session, well, the thing is, I like when I give sessions not to just talk about technologies, or so. It's just create a history. And the good thing is that we actually use this at work. So we handle level 3 support for a bunch of companies, and we do need to be there on call all days. And at some point, we get a lot of requests of stuff that doesn't work, and we need to filter them out and then find, okay, this might be problematic, this might not be problematic. So that's it's kind of a smaller version of what we do, but I think it makes sense that actually I can share what, because maybe people don't know that after deploy you need to do more stuff. It's just not just build something and say, hey, well, I deploy this to Azure and I'll go back to sleep now, right? It
Yes,
doesn't
yes.
work like that.
So
Even if
true.
it seems like that, it doesn't work like that.
So true. So true. Yes. So very interesting. And I can see someone the kernel with the recipe. I can't wait to hear your session. So the stage is yours, my friend Emiliano, with his session, everyone.
Thanks, thanks. Okay, hello everyone. My name is Emiliano Montes de Oca. I am from Spain, and I want to talk about, as I said before, supercharging level 3 support. I'll be talking about support itself later on. But first, thanks for being here, and thanks, Constantino, for making this event, and look forward to be here more times if I can. Just before talking about the session itself, and I want to introduce myself. Maybe it's the first time I'm here. You can call me Emi. It's the short version of Emiliano. I am proud to be the best, like not the best dad, but the proudest dad. I was recently a dad, so I am as happy as I can be. I know your screen is not broken. I have a bunch of tattoos, so it's don't worry about that. I'm a good guy, don't worry. But I happen to love tattoos too. I have a team here at a company called Intelequia here on the Canary Island in Spain, which we do services and so other stuff. I've been an MVP for a few years now, and I was born in Uruguay, so Latin America, and then I moved to Spain, so I'm here. I like here, and I feel way more Spanish now. If you want to find out about me more, you can find me at my LinkedIn, Emiliano Montestioca, or you can write me at Emi Montestioca with two A's, because the one with one A, it's taken, so I have to improvise and and move to another name. That's all about me. I don't want to bore you with about me, but I want to continue now. So as I said before, so before diving into everything, I wanna like throw a question: is that what actually means delivering software? Now, when you're a junior, you think that, hey, well, I'll do my task, and then you are going to commit to a repository, and that will be deployed, and that's it. It works, and that's it. But what does mean really when you are like on a higher level, or you're a senior, or even you're a product owner or a manager or anything? You're actually delivering software for clients, especially for clients, right? It's not just deploying. It's not when the user logs in into the account. It's not when customer does a purchase and you get the money. It's not only that, right? So software. So most people think that software is the shipping software means just building it, and it's not like that. It's really more than that. That's just only the beginning. The real work starts after deploying it. You have to maintain it. You have to maintain the system, handling incidents, improving performance, because you might deliver software and you didn't expect this big amount of low user load, and now it's not performing well, even if it was correctly implemented. So you need to improve the performance. You have to take a look at metrics, and actually, obviously, you have to keep improving it. It doesn't work. You just don't do version one and then you move on. You do version one, and then most likely you're gonna have 1.1 and 1.2 and then 2. So we have a lot of stuff here. So basically, what I want to say is a software itself is a living thing. You need to you need to give it food to keep it working. It doesn't just deploy and it ends, right? And I'm obviously talking about like this software that they rely on you. You have a bunch of customers and they use it every day, so you must maintain it working correctly. But it needs care. So, and this care is what I want to talk about when I talk about software with support, right? So when I talk about support and continuous support and level 3 support, what am I talking about? It's not just help desk. It's not like, hey, I forgot my password, can you give me my password? It's not answering tickets. It's more stuff. It's a structure, multi-layer discipline with support. It's not just any kind of support. And what do you think is multi-layer support? Because I say multi-layer, like we're talking about like infrastructure systems or whatever. What I'm talking about is that we have three kind of levels for this. So we have, I'm explaining it here, but I can talk it to you. So we have support is organized by levels. Not everyone answers to the same tickets because not everyone knows the answer for that specific ticket, right? So level one, level two, and level three, right? Level one handles basic questions and troubleshooting. Like, for example, hey, I can access, and they have the domain wrong, or hey, my username doesn't exist, and you have to tell them, hey, well, you have to register. So that kind of support, and that can happen. You think that doesn't happen, but because we're techie people and we know, but people they click login and it doesn't work, and you get a ticket sometimes. So there's someone there. Now with AI, it happens. You can pretty much not do it manually, or someone doing it. But a couple of years back, when there was no AI, you have to go there and say, hey, well, yeah, you need to click on register and then put your credentials, right? Then is level two, which is more deep support. For example, hey, I cannot see the latest purchase I made. It's not level one because you need to do some research, but it's not level three, which is not like we'll see later, but it's not worse. It's just, hey, the purchase doesn't appear. What's happening? Maybe the purchase is on in process and there's a bug on the system, or the purchase wasn't done correctly, or you are blocked out and you didn't realize because the token expired. So that's kind of the level two that you can expect. And then we have level three, and this is the, I will say, the specialists here, like where you get people that actually build the system or are really used with the system, and they can answer you with for problems that, for example, hey, to say I'm clicking here and I say error 500, and or I did buy something, I have the receipt, everything works, but I don't see the entry on my system. That kind of people on the level three is where you go into the stock trace, you go to application insights, you go to inside the system. You have, by using traces or whatever, exactly what's going on now and why this is failing, right? So um, they we don't really just check the system because I do level two support. We don't really check the system, but we have to fix it. So, for example, let's say, hey, you're trying to do a payment and it doesn't work, and then you see, okay, this is broken because the API, the payments API, doesn't work. Well, it's time for you to actually start fixing it because you are on level three. So it's that kind of work that you must do, right? So now that we know exactly about support, maybe if this is new for you, well, welcome you. If you actually do a good software and you get to be a product owner or you get to the high level, you will be doing level three support. That's how it works. Or maybe you are doing it and you don't know, but that's the name that's the common name of for support. When you're taking care of the software after developing, well, you're doing level three support. But now obviously we are at AI, Azure AI Connect, and we have to talk about AI, right? So we in our company we decided to do some AI because we also push lots of AI on our staff and our clients. We wanted to do some AI in here. So when you layer AI on this, it's where you get to do less work. Well, not less. I don't want to say less work, but your work you can detect more stuff without you noticing, because in the end we have a bunch of traces, a bunch of requests, a bunch of everything, and then you need to go one by one checking, okay, this might be level one, this might not be level two, or this might be level three, right? But with AI, without AI, you're waiting for the user to actually report the error, or you're waiting for some anomalies in both systems, and you need to correlate, hey, I have a error in this microservice and I have another one in this microservice. So these correlates, it's completely different traces, completely different systems. You have to manually actually take a look at everything. And with AI, you can actually start telling the AI, hey, can you take a look at the stuff that happens on my system while I'm asleep or something, or in the middle of the day, or so. So you can actually use AI to be proactive, right? And that can help us, especially our support tree because you need to find that the payment, the message from the user say the payment's broken, um, is actually because of the level 3, or it's because they, we have an outage on our system. That's some kind of stuff that you can find out. So let's start now. So yeah, sorry about the change directly to Azure Functions. Maybe I should talk about from what we have already. So Azure Functions is because we on our system we leverage all our tickets that go into like a, if they're coming from here and then go to here, we always pass by Azure Functions. And in Azure Functions, what we do is that each and every request we do gets in there, and then we analyze it somehow, right? But before starting with the full thing, I want to maybe talk about Azure Functions for the people that doesn't know yet what's an Azure Function. Most likely you already know, but maybe it's just it's a serverless computing service that from Microsoft. You can run it stays there. You can run it. You call it. It runs, and you have a um, bunch of types of Azure functions. You can call it by HTTP. You can have a timer. You can have a MySQL code running, calling it. You can have a Cosmos DB trigger. You can have an event-driven trigger too. So it's basically it's a serverless service that you can just, it runs on Azure, and when you call it. It's sometimes I don't know how to explain it correctly, but it's just you deploy it in there. It's like an API. It's always there. Usually you don't pay anything because Azure, they give you a bunch of millions of requests free, and then if you scale it, then it's not that much. But you don't really have to care about the infrastructure. It's just you just deploy it. You don't really have to think about having a VPS or having an app service or whatever. It's just like in there in Azure, and then you have an endpoint and you call it, right? What it makes it special is that it's event driven. In the end, as I said before, your code responds to something. In the end, it can be an HTTP, a message. It can be a message appearing in the queue. So, or maybe you are actually uploading something to blob storage, and it boom appears, and then that sends a message to my Azure function, and it runs something because maybe you need to analyze, or maybe you see that there's an error. For example, and this error creates a txt file inside somewhere, and then with Azure Functions, we can get alerted and then run something in there. That's stuff that usually happens on systems. Also, Azure takes care about scaling and billing and everything. So you just, in the end, as always, I love Azure, I love Microsoft. You just put the credit card, it kind of works. That's the magic of Azure, right? And basically, what do we solve with this? So before Azure Functions, we basically had to have servers running with something in there. For example, if you have a HTTP trigger, we will need to have a service running 24/7 with a web app, and the web app has a controller, and the controller has an endpoint, and then you call it whenever you want. Now, when it's called, it appears. Let's say not appears, but it works. It's always there, but then it's sleeping, and then when you call it, it works. So you actually pay for the time running and not for the entire 24/7. If you have a blob storage and you're uploading every hour, well, we have 24 calls per day. It's not always running. It's most likely going to be cheaper than running it 24/7. Also, well, besides that, the entire scaling and everything, you actually Azure takes care of everything. So if you are getting millions of requests, well, it's going to scale accordingly, and it's going to be fast. So obviously, all depends on the amount of money you want to spend, right? And let me go here real quick. This is my Visual Studio. I'm running on Windows, so this is pretty basic. And let me create one with you. So we can do functions here. You don't really need anything. Well, I'm lying. Actually, you do need. So you do need the functions tool. It's like an CLI, because you can actually debug and run functions on local that you couldn't do this before a couple of years ago. Now I'm getting older. But now you can do it. So you need to install some kind of function CLI, and then you can do everything. You can even run time triggers, and I think even blobs and everything. You can have pretty much everything. So you don't really have to guess how it works and then go to production. You can actually do it the local. So let's go in here, and you can see the thing is I want to show you is the. I know it's small. One second. So basically, what I'm going to show you is this. This is the amount of stuff you can run it as functions. As you can see here, time trigger. It's basically you can do a cron here, so it's like every 5 minutes, every 10 minutes, every 50 minutes. So well, because maybe you need to do it, and then you need to do, for example, you can have a Azure function that actually does system cleanup every hour or every 2 days at night at 4 p.m. You can do that because it's actually using cron. You can have SQL triggers or inputs and output binding. So let's say that you have a trigger, and when you do a delete in the user, you want to actually run a trigger because you want to delete all the assets that we have in the blob storage. That kind of logic, you can do it. And that's something that no one thinks, hey, maybe they built an entire system, an entire complex microservice for deleting stuff from the user, and then hey, well, if you do this, you just listen to some trigger, and after that happens, you implement the delete, and that works. But we have a bunch of them, like service bus, and then Q trigger, MySQL stuff, Custo. If you have application insights, you have HTTP trigger, which is the one we use, event grid, event hub, or whatever you want. It's a bunch of stuff. And if you create it, let's do it in here, HTTP trigger. I'm not putting on Spire yet. Give me one sec. It's not my best laptop, to be honest. But as you can see, it's basically we have a function, we have the logger because we want to log. I know you guys all log your applications, and then we have just basic HTTP stuff, and then with the name and basically it's an HTTP entry. So this is a function, as simple as that. You can do anything with this, right? So this is pretty simple, right? Let me continue with the slides because I want to move onto actually the AI before going into the entire thing that I built, which is what we use on our own work. So now this is the other part, and this is semantic kernel. This is where the part of the intelligence we get in here. So the thing is, we need somehow to add AI to our system. Now everyone knows. Back in time when semantic kernel was new, it was a pretty wow moment for everyone. But now you used to need to add AI to your system. Everyone knows how to do ChatGPT or go to Cloud or go to Perplexity and they, hey, I need help with this, I need help with that. But how do we implement this in our software, not outside of software? I don't want to leave my software to do stuff. I want to do it inside my software. And how does it work? Well, basically semantic kernels, first of all, is I will say it's I don't know, it's open source SDK package, Nugget package, library. You can call it whatever you want. But basically, it's a library that lets you call AI and do stuff with AI inside your application. It's like, for example, maybe put an example is easier for you. Is if I have some text on my, let's say a user I need to do some summary of text that gets into my system. People, I know this is for a fact that they get text and go to ChatGPT and do summarization there, which basically please don't do that because it breaks the enterprise rules most likely. So never use ChatGPT for work. Always use something closed or enterprise because you're training data with that and you get your client's data there. But in any case, we using semantic kernel, what we do is that inside our program or application or web, we can call ChatGPT using Azure AI Foundry, which it's safe for enterprises, and then do the summarization there and show it in our place. So that's the kind of library I'm talking about. It lets you integrate AI into your application. We're not leaving our applications yet. So the thing is, I think that semantic kernel itself and how this is how Microsoft labels this is like an enterprise middleware for AI. It's they tell you use this if you want to add AI to your application. Don't use anything else. We do everything for you. We let you talk. We let you do everything with this. So use it on enterprise. Thiago said something about before that about the Microsoft Agent Framework. So Agent Framework is, I will not say it's better, it's different. Semantic kernel will not die, or for now we will not die. We know about Microsoft killing spree sometimes, but we can have Agent Framework, which is for all other stuff. So we have a couple of things inside semantic kernel, which is you can have your persona, you can have your plugins, you can have your everything you want, so you can use it to talk to AI, right? So and also you can talk with any AI model you want. It's not like it's not close to using to OpenAI in Azure, but you can talk with a standard. So if you have the API for Cloud, if you have the API for Perplexity, if you have the AI for Meta AI stuff like Oyama, you can even run it on local. You can even run it with Azure with Foundry local. So you don't have to rely on having this on Azure. So it's not really connected to Azure. They just build this and it talks with the standard way of talking, right? So what can we do with this? And I'm closing this and I'm showing the code now. And maybe let's do it here. So basically what we built in the company is that we get messages and then they go, we trigger an Azure function, HTTP call. The Azure function uses semantic kernel to analyze the call. And then we say, hey, well, we got that someone saying, hey, the payment service is returning error 500. That's pretty level. That's pretty crazy because, hey, we should never display the error itself. And maybe, there's an outage, and then we need to send us a notification, and then I don't know, call someone, etc. That's what we do, right? So I created this thing on here in our beautiful Visual Studio, which basically does that, right? But first, let's do it because I think I have some time. I have some time left. I think I've been talking for so much time. Basically, what I want to do is actually implementing semantic kernel. So you actually know that, hey, maybe in a couple of lines I can actually call my AI, right? So first of all, I have a couple of things here. I have my endpoint API key and deployment name. This stuff, in my case, it comes from my own Azure Foundry. So I need to get the project and then get my API key, right? And then I don't click here because otherwise you get the thing. And then you need deployments, which in this case they call it deployment names, but this is like actually models. But you can name it whatever you want. I can call this my little AI, and then the name itself is GPT-5 or something, right? So in this case, I will be using, I think I have a 5 nano here for testing, but this is where you need this, right? You can, as I said before, you can use Oyama local, and that's it. You don't need API key or anything. You just run it. So I have installed some packages, as you can see here. So what we need first to talk to AI is a chat service, because otherwise, every interaction with the AI is always a chat. It doesn't, even if they tell you, hey, you're talking with the AI, you're always you always need to chat with someone, right? So first of all, let's to create this chat service, right? So let's do chat service here. If you help me, I am not going to bother writing this if my Copilot helps me. So basically what we are adding here is my Azure OpenAI chat completion service. This is like the service that will let us talk with our AI, right? We need, as I said before, the deployment endpoint and API key. So if I go control IP, you see initialize an instance of the Azure OpenAI chat completion service class and says deployment name, endpoint, and API key. You can change it but there's other constructors, but we will use this one. So, and with this, what we can do with this? So, I don't know, let's do something. Let's do, I don't know, sponsor something. Let's see what chat service let us do. So, wait, chat service, and then we'll get some methods here. So, we can get as chat client, get chat message, get streaming chat message. So, you're going to see the like characters appearing. But in any case, we will be running chat message. And then we will do the magic word, the magic question I always do all the eyes. What is the meaning of life? Right? So now let's do some basic console write lines. It's not response doesn't want to copy, but and then I am going to run this, and then it's gonna take some time because now AI is better, but it takes more time. So because I don't know, I'm asking, and it sometimes need to reason. I'm gonna make this big one so you can see it. Give me 1 sec while it loads. I can make it faster because it's not me doing answering the question. And if I had to answer, I would say that the meaning of life is my beautiful daughter. But in any case, you can see I have a message here. So it may be I have a message here, and I want to show you that we got this in what? 1 line, 2 lines, that's it. So we somehow created magic here, and we created and we created AI on our system. So I know this is a stupid demo, and I'm sorry for that, but I want you to keep thinking. Okay, what can I do on my systems now? It's I know that everyone is vibe coding stuff now, but if you have existing working system, I'm sorry, but it's not gonna vibe code it so much. You need to add AI into it. This is the way. So, but there's more stuff that you can do. This is simple. And now that we have the meaning of life, let's maybe do a chat button on this. So let's do control KS, and then we do, and then we actually ask the user for something to say. So let's do console. I lost my thing. Okay, so let's say console right, because I want to do this like thing, like kind of beautiful. So we do question, and then we get the value. So the question is actually console read line. This is pretty basic code that we got teach before that we don't do anymore, right? And then we are going to use the question for this. And then let me do this. We pass the. It's not copying it when I want it. Next question. And then we do this, right? So we do this, and then here. So basically, I'm doing a small chatbot. I can talk. I can just talk with this. This is pretty simple. This is not nothing. I didn't change anything. I just changed the way I interact with the chat. So basically, this is asking me questions, and then I'm replying. So I say, what is the meaning of life? Right? Now it takes some time again thinking about the meaning of life and why are we here, and okay, now and you have it here, right? There isn't a single definite answer for whatever, right? And then if I tell, hey, what was my first question, right here, and I guess it's going to know, hey, I'm gonna tell me, hey, well, you asked me about the meaning of life, but then it says this is your first question, and doesn't make any sense because I know for a fact that here I actually ask what's the meaning of life, right? Well, it doesn't work that way. AI, this thing doesn't work like that way. So let me do a small drawing. Sorry, I suck at drawing, but I'm gonna try. So we have our client here, and then we have our AI, our AI here. So whenever I'm sending messages, this is doing something like this. So it's one message and then get back. And there's one message and get back. There's one message, right? So as I said, it sucks. I'm suck at writing, right? What we can do, which is actually what happens on under the hood on all the AI applications you use, is that we create a small package here and say, hey, well, I'm going to ask a question here, write it. And then it goes back. And then this says, hey, okay, it's not here. This is the answer. And we put the answer here. And then we get this back here. And then we do the same n amount of times. And then we get a bunch of history, right? And this is where it gets complicated, right? And I'm talking about super complicated stuff. Like if you want to implement just history, you have to like think about threads and multitasking and everything. Or you can do just history, and that works too. So you do just history, and then you, instead of actually using the sending the question itself, you can just do add user message, and then you question, and then I think that's it. You actually now instead of giving the question, you actually send the chat history. I was trolling when I said it was going to be super difficult, but basically what we're doing is that create like this small wrapper of questions, of responses and questions, and then just type it here. So now let me do this again. So okay, so I say, hey, my name is Emiliano. And so I say, hey, nice to meet you, Emiliano. I hope you're nice. And then if I go back and say, hey, what is my name? Well, we already know. It's pretty simple, but in about 2 lines, we actually added history to our chat, so our integration. So keep in mind, for example, in your systems, if you have an integration in your system and you need to keep multiple messages from the customer or multiple messages from your user, well, you can do it with this. Obviously, you do this differently. Maybe you save the messages on the database with the timestamp or with an order or whatever. But you do it with this if you want to keep the token, right? But then we can do more stuff, right? Because this is simple. But what if I have stuff on my application that actually needs to be called? For example, let's say that I have a system where I need to, whenever I run this code and I ask AI, I need the AI to actually go and fetch the information somewhere and get it back. For example, if I actually if I actually need to know the age of the user, or because I have it on my database, because that's something that can happen. Maybe maybe the user is asking me, hey, I need to add something and use my age for it, and the AI will be like, oh, buddy, I don't know, I'm trained with billions of parameters, but not most likely not your age, right? So we need to add something which is called a tool. A tool is basically a function that can be used with this. So for doing that we want to create a pretty simple tool, which is basically give me my name, give me my age, right? So let's do it, and let's look at age plugin. We are going to create an age plugin. This is the most basic C# code you're going to see. Don't expect it to be better. Get age, and then we do string name, because we need to have a name, and then we're gonna have a switch. It's so simple, man. I haven't write this in years. I hope my work was like this every day. So we do Emiliano, and I'm 31. Jesus, I'm old already. Return 21. And then in case it's my daughter, which her name is Valentina, she's gonna be actually 1. Not yet, but she will be. Return. Right. So, and then basically, if not, return -1. I don't know. It's not gonna happen. And then now we need to actually tell the AI, or not tell the AI, the semantic kernel, to actually use this. And this is where it gets tricky, right? This is where we specifically use documentation to learn how we do this. And we basically have to add a kernel function here, and that's it, and it works. And then you actually, like, I don't know, tell AI, hey, you have to look into here to do this, and then you do descriptions. And because when you are using AI for everything, we actually tell the AI what to do. So we need to tell the AI, okay, this function does something like this, for example, gets the age of a given name, right? And why we have to be so at the description, because this can be called get age from the Spanish people or whatever, right? So you can actually add anything you want to the function itself, but then you have to change this, and you use the description. You need to tell AI stuff. We're talking now, this is a two-way conversation now. If we want to actually use this, it changes a little bit, because here's where the tricky part gets, right? So we need to do a kernel, because the kernel is like I don't know how to explain it, but the kernel itself is like this container stuff, or this configuration slash container that you're giving the client that's going to talk with the AI, with adding possibilities like services and these tools and everything, right? So here is where the magic happens, right? So first you need to create the builder, right? So there's a builder, like everything with kernels, you create a builder, and then you create kernel. Thanks, create builder. I don't have to write it. And then somehow at the very end, you do the building. So you do the kernel, and then kernel, and then you say builder. Create. It was build kernel, right? Yeah, build. You're right. I almost forgot. So in here, whatever you put in here, is going to be added into your call with AI. Right? So in this case, we are going to add the tool. In this case, called plugin. But yes, please, I don't want to do it. So we're basically adding, saying, hey, to this configuration, I want to add the plugins, and the type is the age plugin. So it matches this one. This one matches with this one, right? Pretty simple, right? So far, I am doing a first grade programming here. And then we can try to run it. Just won't work. Because why? Because you need to actually tell the AI, hey, you might as well want to use this. Because by default, we don't. By default, we say, hey, don't do it. Just in case, don't run any of my code. And in order to do that, we need to actually create the prompt settings. And this is where we can modify stuff. For example, say, hey, well, I want you to actually, I don't know, use this amount of tokens only, or the level itself, I don't know, the temperature, it will be 0.5 or 1 or whatever you want, right? So we need to specify stuff. And in there is where we say, hey, well, use this stuff, right? So for that, we're going to create our prompt settings, and they are called new Azure AI prompt execution settings. Correct, right? And let me do this, and then let me show you what we have in here, right? So we have audio, Azure chat data source, frequency penalty, max tokens, as I said before, metadata, modalities, modality. Oh, this is new stuff here. Temperature, so it doesn't like go crazy or whatever. And the one we want is the tool called behavior, because we want to get or set the behavior of how tools are handled. I'm actually reading the description. So I don't know how was this, but yeah, you go. So we have a bunch of them. So we have enable kernel functions, auto invoke kernel functions. That's it. So we basically do auto invoke kernel functions, right? And now that we have everything done here, we created our builder, and then we did some stuff in there, and then we had actually build the kernel. And we said, hey, I have everything. Now I need to actually use it, otherwise it won't work, right? So chat history. Then we can add prompt settings, and then we can do the kernel. Now I'm going to put this in here just in case you see that I'm not lying to you, because maybe the AI knows my exact age. So I'm going to run this again. Basically, I'm going to do the same questions once again, and then we're going to check that we have a history. So I don't know. My name is Emiliano. Sorry. I'm just gonna say, hey, hello, Emiliano. How are you? Hopefully it doesn't tell my age yet. So what was my first question? And then it's gonna say, hey, it was message. It wasn't another question. So actually the AI is smart, most likely smarter than me. So I can tell you what is my age. What is my age, right? And then it's gonna take some time, and hopefully it will do a breakpoint here on my debugger. So actually it's using my code, as you can see here, is actually able to get my name, and basically what we're going to return is the name, is the number itself. So it's gonna tell, hey, well, you're old as fuck, right? So we actually got this running here. So we created our middleware in our system, we gave it possibility to run our code, and it works, right? Now you can change how it behaves. I think now, if in 2026 now, agents, this is by default, you have instructions to your agent. But before, when we had semantic kernel, it was called assistant message, right? So when we create our chat history, we can actually tell the thing, hey, I need you to behave this way. That's how it used to work before. Now it's by default, but before you had to do this manually. So you can say chat history here, and you can add a bunch of stuff. And in this case, I'm going to add as an assistant message, and the assistant is going to be, you always answer with a short joke, right? So we are going to run this again. I want to remove my debugging point. And then we are basically touching every point of semantic kernel, and that will be done. And then I can move on with the stuff, right? So I'm gonna tell, I don't know, my name is Emiliano. Most likely, I don't know the joke it's gonna take. Hopefully, it's something funny. Let me make this bigger so you can see it. I think, yeah, you can see it. Nice to meet you. I bring a ladder to the bar because the drinks were on the house. What is my age? Jesus, that's actually a bad joke. Let's see what it says. So I'm gonna get 31, but I'm gonna spec the joke. 31, congrats, you're officially vintage. No way. Well, we got this running. So as you can see, we got everything using semantic kernel. We got the AI, we got the functions, we got the persona, which is now it will be an agent, right? But we got everything here, right? So what did they build actually? Now let's move on with support again. So what did I build? So first of all, for this specific demo, which by the way, I'm going to put everything here open on GitHub, so you can download it and test it yourself. You just need the credentials. Basically, what I built is an Aspire thing. I want to run it in the meantime so it opens. So I built a solution where I have an Azure function, an API, and a Blazor web app. So I'm going to have my Blazor web app having messages that I can send, like, hey, say, hey, well, this is broken, or it doesn't work, or whatever, right? And that will go into my API, which in the end will go to my function and say, hey, can you analyze this, right? And how is this working? I'm checking the time. I think I'm fine. I got 10 more minutes or so. I don't know. So basically, if I go here, let me open it here. As you can see here, I have if you haven't heard about Aspire, it's a way of orchestrating local apps. Well, apps that require, or not require, but they might have a bunch of microservices. And if you don't know how having work with Microsoft, 15 of them, it's a nightmare to run in Mobile. And you need like a NASA machine or something, because what do you do if you have 3-4 databases? Well, use this. If everything gets orchestrated, you can programmatically orchestrate everything. So I have this. I have my front end, which is my Blazor web app. I have my functions, which is the function that actually does the logic in here. I have my API service that actually calls the function. It's like a wrapper in there because I might need it or not. And then this is the storage for the blob. This is something for running Azure functions on local. Right? You need it's called Azure, but it's some kind of blob storage. You need to have it on local. So the system works this way. I at some point I need the function. So the function, let's put it on the right side. So this is my Azure function, and this is the one that talks with my beautiful AI here, right? So this one talks with AI, gets the response back, and this is tells me, hey, well, this is actually level 3 or level 2 or level 1 type, right? Then in here, I have something else, which is my API, which is actually the middleware between talking to Azure Functions or not, because maybe I need this to call from someone else. So I create this wrapper on top of this. And then I have my place wrapper, right? This is my, let's say that's the client's, I'm gonna say SaaS, right? So it's a SaaS that generates some messages sometime, and then they get picked by the API, and the API goes to the Azure function. The Azure function says, hey, well, this is broken. Notify everyone, right? It's not notify stuff is not implemented, but basically, if you have a phone number, it will call you, say, "Hey, it's broken, fix it, or we're losing money." This is exactly what clients tell you. So let's go to the front end stuff. It's pretty basic. Maybe this is too small. Hopefully not. I'm gonna make this bigger. There you go. So standard Blazor application. I love Blazor, by the way. I do everything with Blazor. So if you want to know more stuff about Blazor, you can get in contact with me. I like it. I created this exception tester, right? I created it, and when I say I created it, I used Cloud 0.7 back, because this is an old version. So I vibe code it, obviously. Everyone vibe codes. I'm gonna be honest with you. I like to program, but I also like to architect more. So basically, what happens is that if I do level 1 forgotten password here, this analyzes an exception. I'm gonna show the trace now. Check if the Azure functions. I like it. I like it when we break stuff on. What did they break in here? Let's see. Finish. What did we break? Let me run it again. I like the demonstration. So do I have Docker running? It's my Docker instance here. Nothing like breaking the demo itself. Let me stop this, maybe. Let's see. Nothing like breaking demos in a thing, but in any case, I can show it anyways. If it doesn't want to run, why force it? Hopefully it works. Let's see. Aspire, is it working? Oh no, that's unlikely if it doesn't work. I don't really have a backup, so let's see. Web front end. It's unlucky. Let's see. So let's see if it works. Personalizing. Did it close or analyze? Oh, there you go. So it was kind of broken, but now it could fix it by itself. The magic of vibe coding the stuff. So basically, what I'm doing is sending the message. Hey, it doesn't work, right? And how does it work on the back? Right. So if we go to here to Aspire, if you don't know, this also gives you telemetry, and you can check all the structure logs and traces, right? Sorry. And in here, you can see that we're calling from our web app, we're calling our API. And actually, we're going to run functions, and we're actually calling the functions. What does this function do? And this is the best part here. It's super simple, right? So let's go to functions, and it's a pretty simple function. This is a post, and it requires a request, right? I'm sending stuff to it. What am I sending? Let me maybe go to the API first. We're about jumping between the stuff. So the API gets report, and then we build an exception report, which is basically message generated from API, minimal API, and this timestamp, and then user, and then it gets the function error because you need it. In this case, we're using Aspire, does the entire orchestration and the routing by you, and then gets the sends the message there directly. So I actually think that the placer is sending to the function and not with the API. The API is for actually using two different sources for the function. It's I think that was supposed to be doing. So I lied to you before. So we can actually go to the placer web to see that. See, this is pages and then home exception tester is going here. This is basic Blazor 2. Handle exception. Where's this? Come on, let's go in here, and then there you go. Now report exception async. There you go. Let's see in here. Okay, there you go. Now we're talking. So Blazor directly talks with the function and basically sending the entire thing. So you can send the message, and the function is the one that actually does the entire checking on there. So if we actually now go to the function itself, sorry for jumping between one and another. First, we read the message that we get either from the web API or either from the Blazor. We are going to analyze it, and then we have it in here. So analyze exception async, and now you're going to see a bunch of stuff here that's going to remind you from what I showed before. I actually see kernel already, so that's something that we did before. We don't see any kind of credentials here, and I'm going to explain you why. Is that you can actually register the chat service as a service of the system itself. So if you've been doing dependency injection for a while now, which I guess you have, because we're using .NET now and the newest versions, you can actually create the kernel and the chat system, sorry, chat service, and inject it to be used everywhere. So, for example, if let me show you. If you go to program here, you can actually see that we are actually configuring semantic kernel and add it as a service, as a global service for everything. Here, we could be actually doing case services, so you can add the specific service to be like the analyst service, and then you can add another service with another configuration and call it by another name. They're kind of making agents now too. So this is how I am now registering my chat service. And if I go back here to my kernel function here, no, here, right? So I get my service back, so chat service, and you can see I'm actually getting from the dependency injection. I have to do some prompting now. So we need to tell, hey, you're an expert support triage system for a software application. Your job is to analyze and then separate them, and also tell me, hey, well, we need to alert or not. So we obviously have to give it some examples, like level 1, level 2, and level 3. So level 1, user-related issues, don't affect system operations, like password resets, login issues. Hey, well, UI, I don't know where the button is. Oh, he's here, so the description. Level 2, severity, can be personal data, or orders history, individual features not working correctly. So that's something that should happen, and it's not just, it might be a bug. No? And now level 3, system-wide issues, like provider for payments doesn't work, and there's getting 500 from the API and security vulnerabilities. So that's something that we need to step into. Right? And at the very end, you tell the AI, hey, well, this, now you're going to return me with data. And the data itself, because now, if you talk to ChatGPT, it's going to tell you, hey, I have analyzed your stuff on this level 3. I want a specific return. And this is when telling them, we tell, hey, you can only respond with a valid JSON, because otherwise I can't parse it, right? So you need to do something like this, and then you say support level, classification, severity, explanation, and if it requires an alert, right? And obviously, if for level 3 issues, set required alert to true. I could say if level 3 was 3, then it requires alert true, but let's make AI do it for us, right? And then we say this now. My user prompt is analyze this, and then we get the data here. So we get if we can have additional data or whatever. So we do the same as we did before: chat history, system message, user message, and we get the response. So let me put a thing in here, and then let's do whatever. I don't know. Let's do fancy orders now. It's analyzing. Let's wait a little bit until it runs. Hopefully it doesn't. Okay, there you go. So if you go back here, chat service, we have it. System prompt, we have it. How was the user prompt? So user prompt was analyze exception, unauthorized access exception, customer ID, unable to retrieve all user retrieve order history, session timeout, and whatever. So we are actually sending stuff, right? And then what we're doing here is, let me get the response, right? Let me do an 10 here, and we can see that, okay, then it says, hey, well, this should be level 2 or level to retrieve or the history, and then an explanation, right? So we actually can tell AI, hey, explain this, because maybe I can actually explain the customer, hey, this is what help, what's going on, and then we can enforce, I can even help our level 2 support without having us to actually have someone say, okay, this is what happened to you, you know. And even it's actually recommended actions like ask the user to re-authenticate, verify session timeouts, and check tokens, or maybe clean cache or clean cookies or whatever. That usually happens, right? But we can tell AI to do it for you. In this case, this is for level 2, right? And as you can see here at the very end, you need to do this. You can see the AI result. Actually, this parses everything. So maybe response text now it will change. And as you can see, we have a valid JSON as before, but this is for checking that actually it's a validation. Otherwise, we fail the parse and then everything, nothing works. Right? So in here, we have everything. And our result at the very end is actually an object. And this is the object of our JSON parser. And now we said continue here, and if you go back here, sorry, well, it fails. Sometimes it breaks. This thing, this emulator sometimes like to break, and I hate it sometimes. Oh no, maybe this was because it was a timeout. So let's try again, and now we do it with a level 3 service. So we're here again. Let's see, and there you go. So response is maybe one other more. The response is, hey, well, this actually requires your support level 3, connection with discussion, external API 500, inventory returner 500 error. So this actually requires a support, an alert. So if we run this, we hear, hey, alert trigger, this is a level 3 support issue requiring immediate action. What will happen if you run this here? So ideally, and I'm telling you what happens in real world, is that I actually will get a call right away and say, hey, Emmy, you need to wake up now. If it's 5 at night, you need to wake up now because inventory doesn't work and we are returning a 500 call. So this is where I don't have to wait, or there's nothing, because there might be more errors on the data on the system, and it's actually analyzing that one and say, hey, well, this looks bad. There could be lots of errors. There could be lots of entries on the database on your login system or your Grafana on your application side saying, hey, it's a 500 here. But not all 500s are the same, it's a good thing. Not all errors are the same. The ones that actually hurting our business are worse than the one that the system say there's an error 500 here. So here I say it's let's say that our application inside has and this is where we start to link everything, is that our application inside has a rule where every error 500 that we get, we send it to an alert. And that alert actually goes into our Azure function. That Azure functions actually does the entire analysis and notifies someone. So this is where we start linking everything. And this is where AI helps us, because otherwise we'll get an alert or an email on our mailbox and say, hey, there's another 500 here. Or maybe we get thousands of 500s a day because session expires or whatever. But between hundreds, we need to find that specific one that is actually worth taking a look. We do it with this way. We do it with an Azure function, listen to our message, and doing it on the back. I think that the other service is not implemented here. Let me check. Yeah, you go. In real world scenario, you will send an email to support team, create a ticket system on Jira or ServiceNow or whatever. Send an SMS or push notification, post to Teams or Slack, and then trigger pay duty on the system. So you actually will get a call. This is how now it works. This is how it works. This is how AWS works, with Microsoft works. You get something like this. So just to do maybe I can do it in here. So to do a clear diagram before finishing, is with customers, and because I like to actually draw a lot. So I got this customer. We have our application, and then we have and this is how it works for us. I'm going to give you a clear blueprint of how we do it. We have an application that actually runs on Azure. This is our beautiful Azure here. We do Azure, right? And then here we have no, that's here. There you go. Here we have in here we have application insights. So we have app insights, right? If you don't know what application insight is, it's where you send metrics and you can check in there with using open telemetry and everything. So you send metrics to there. So this application insight has something which is called alerts. So you can have multiple alerts. So for example, you have a low usage, or you have custom alerts like you are not getting enough messages, or you are doing too much stuff, or your CPU is 99 at the percentage or whatever. So we have alerts here. So this is alert one, alert one, alert one, alert one, alert one. This is alert 4, 3, 2, and 1. So we have a bunch of applications here that work, and then these, the customers, which are outside our Azure, they do stuff here, right? And then they go here, and they go here, and they talk with them, and then they do stuff, right? So every time we do anything in our application, we log it on application side because it's mandatory. We need to do it because otherwise we don't know how the system works. So we go here and say, hey, this happened. Customer login, customer did a purchase, customer did this, customer did that, customer did that. And this is being saved here, and millions of rows, right? For everything that happens, we have it in here. But let's say that this application here, so this part here, which is or this one, which is the payment service, actually user went here to the application, and then the application went here, and we get a 500, right? So this 500 gets actually logged also here, right? This one, we have an alert for each and every 500 to do something. And to do something goes into here. And what does it do? It goes to our big Azure function, right? Which is not only one, but in this case, I'm going to make it one because you can have analysis, but multiple analysis per function. Let's say that one function analyzes errors, but another function analyzes purchases or whatever. So this error itself goes into an Azure function, and this one is the one that decides actually, okay, this is worth level 3 support or it's not worth level 3 support. Because maybe the error 500 is that the session expires something, and it doesn't make any sense to actually create a level 3. But maybe the error is token expire for a Stripe account, and that's critical. We need someone to actually go generate the key and then put it back on the system and reboot everything, and it works, right? And in here, let's say that we have our beautiful people here working on the team. So these are us, the workers. So we get notified here whenever something happens, and then we go back into the system, and then we fix it, and we go back. So this pretty bad drawing is how level 3 support works. I'm not gonna say most likely on the companies, but pretty much on. I guess that's something like this. There's someone looking at something, gets notified workers, working, gets back and fix everything. So what else? Well, obviously on the application you can do whatever you want in here. You can actually say, hey, well, I went into the system and the domain, I don't know, the domain is unsafe or whatever. Let's do it. Let's see what it does. If it works or not. Let's see. Let's see. Maybe it's level 2. Okay, there you go. The user reports message domain is unsafe. So maybe it's actually the SSO certificate expired. That can happen. You have monitoring for that, but maybe you miss it and then you get it. Like customer says, hey, when I access the page, it says unsafe. Well, you need to go fast, otherwise you're gonna lose the people joining because they don't want to access, or maybe it gets lost on Google or whatever. So let's see what I have it back. If I go here, what I have in here. So last thing, we saw everything that I mentioned here. So we found the Azure function triggered by HTTP calls. We saw the Azure function using semantic kernel to analyze the call. We saw big cell, right? Big if the send telemetry exception notifications. And we saw that we are using it either from the Blazor application, or in this case, a minimal API, so it's a normal API, or it can be used by any other application type. And in here is where I say it can be used by the application insights alert, right? So you can configure this so whenever something happens or there's more than one exception, actually send it to the Azure function. This is natively support, and you can see it on Azure. It just works. Maybe what I have next in here. Maybe I think that I was going to do the like show me everything, but I just went too fast and then skip the skip the thing. And I think that's it. I don't know how it's time. I think maybe I overdo it or I'm too less, but that's it. That's it. Thank you. I need to publish the the source code. I think it's there on GitHub already. I can let me show it. Azure. I have it. Azure AI Connect. There you go. I have it in here. I mean, will go back if I have it in here. I have it published here. It's most likely private, but I will do it. I will send Constantinos with the repo so he can post it later on LinkedIn or on the chat. As soon as I clean up if there's anything here, you can find even the slides. Yeah, the slides here you can find both with notes or without notes, just in case if you want to take it and give it in your user group. I don't really care about you saying whatever I said before to someone else. I don't own this. I just like to share, and you can find all the entire application here running. So yeah, that's it.
Thank you, Emiliano. What a technical presentation! I really loved it. You really like more technical stuff, I guess, than presentations and
Yeah. Yeah, I
you
really
like
prefer
hands-on,
to
right?
show something.
Yes,
I really prefer to write some code, even if we less and less write code, because let's be honest, I
yes,
pretty much don't write code anymore. I analyze it and then just think how it should work. But whenever I have the chance, I prefer to go back to the basics and do some console apps and say, hey, well, you still can use the fingers to
yes,
write the code, you know?
yes, yes. I really liked it. So yes, please remember to share with me when you have some time the public repo link. I
Yeah,
would
for sure.
probably take your code and try to implement an actual front end and a back end and make this a complete web app. I really like creating web apps, and having the code in the background, so we
Yeah,
can kind of contribute there. Thank you so
for
much,
sure, for
Emiliano.
sure.
What an
Yeah.
amazing session. It took some
Uh,
time, but not a problem at all. Our next speaker is right on time, so
oh,
we are
thanks.
flowing perfectly today.
Good, good.
Many thanks,
Then,
Emiliano.
Constantino, thanks a lot. From my
Yes,
side, thanks a lot to you for doing this and for letting me be here. You can count on me on any event. I'll most likely be there for you and make a session up and have some fun, because at the end, I think that I learn more from teaching and from showing than actually just from reading. So I like to show what I learned from other people. So yeah, thanks a lot, and hope that everyone else remains here and keep learning, because there's some amazing sessions I've seen.
absolutely. Thank you so much, Emiliano. The honor is mine, of course, and hopefully we will meet again.
Yeah.
And I would really like to meet you also in person. Time
Yes.
will
Let's
show.
see you on the summit if you go.
Not
See
this
you.
year. If
This
everything
year?
goes well, next year.
Okay. Okay. Then
Okay.
see you. Bye.
See you, Emiliano. Great. Excellent session from Emiliano. It took some time, yes, but nevertheless, it was quite interesting. I have our next speaker in the queue. Let me play a quick, intermission video, like grab some water and everything, and we will be right back with Joey Curtis. A very interesting session as well. So see you in 2 minutes, almost 2 minutes. So, Azure AI Connect 2026, we are on day one. We are in a amazing flow. I can say everyone is right on time, and we are quite flowing, as I said earlier. So together we have with us Joy Curtis. Joy is going to let me add Joy in the stage. Hello, Joy.
Hi, how are you?
What a pleasure to have you with us. I hope you're doing great. Where are you calling from, if you don't have a problem?
I'm from Utah in the United States. So
Oh,
that's
great.
where I'm from today. Yeah.
It's late there. It's quite late.
It's like that morning. So you were catching me on a different time, but not too
Oh
bad.
my God. What an honor to have you with us such difficult time. Thank you for being here. And your session is about AI beyond the sales pitch, a project manager's ABCs of implementing innovation. We're getting away from the deep technical stuff that Emiliano showed us a little bit earlier, and we're moving into a more high-level approach from the project management perspective, if I may, which you're, of course, going to explain to us. So, Joy, I want to thank you so much for being with us, and it's a pleasure to meet you now on stage. Uh, and yeah, you're on the driver's seat.
Well, welcome. I'm super excited to be here. Just as my introduction said, I am a project manager. So we are moving, my discussion is a little bit out of the technical and into more of that implementation side. One of the things I want to emphasize while I'm presenting is that as a project manager, I have a huge respect for the technical development. And the first part of my presentation is how I explain agentic AI and AI implementation to stakeholders. Why is this so important? Is that right now, AI is a huge topic of conversation. Almost every stakeholder we interact with wants some sort of AI, right? But without understanding the opportunities of AI well and the limitations of implementing a generative AI solution, a lot of projects fail even before they start. I often get brought in to explain AI to stakeholders while they're planning their strategy. And so today, the first part of my presentation is ways that I explain AI to stakeholders. You, as I know a lot of this is a technical audience, you as a technical audience understand this is more complex. My goal is to explain it actually really simplified. Explain it simplified so that those projects can start getting live and we can start implementing them. So let's get it in. The second part of my presentation, after explaining how do you get stakeholders to understand what AI is and what AI isn't. So the second part of my presentation is me talking about projects I've actually implemented. I'm all about telling you what went well and telling you what didn't. So when I do my second portion of my presentation, we'll go through actual projects that I've worked over the last 3 to 4 years as a project manager in AI. And I'll highlight what went well in that project. I'll highlight transparently what didn't. My goal with doing that second portion is that you see what these actually look like in practice, moving us out of this hypothetical wanting to implement an AI, which is great, and into this practical implementation strategy. So let's get started. Let's share my screen. I think we're there. Give me one moment. All right, I think that my screen is shared. Oh, I'm seeing the nice little endless loop, so I'm feeling there. Good. I'm gonna put all of you on my other side here and get this into presenter mode. AI beyond the sales pitch. Skills versus how-to, pattern versus thinking, implementation, and experts. Skills versus how-to. This is really important. I want you to all kind of take a moment. Everyone's going to take a deep breath. My background is I do have a master's in education, and then I moved into education technology, and now I predominantly train and do PMing for AI. How does that relate? All about using your brain. So in this, either on your computer screen or on a piece of paper, but I want you to sketch in your mind somebody who is doing a skill skillfully. Okay, so we'll take a few seconds. I want you to imagine, if it's an athlete, a very skillful athlete, just that intuitiveness. In your brain, I want you to imagine someone who is just following how-to steps, right? The difference between how-to is that how-to is step-by-step directions. So for example, this right here is a recipe book, right? A recipe book has how-to, ingredients, first, second, third. Someone who is skillful is like my mom, all right? My mom is a great cook. She makes delicious bread and she doesn't follow a recipe. I've tried to figure it. She's just so skillful, so nuanced. Why I want to start out with the difference between how-to and skill is because oftentimes in trainings, we focus so much on how to do step A, B, C, and then you'll become an expert. My goal is actually to spend a lot of time in skill. How do we develop that nuanced? How do we develop that kind of gut understanding? And arguably in most educational research, it is a word called metacognition. There is a false belief that if you how to enough, you will become skillful. That is not true according to educational research. How you become skillful is metacognition. What metacognition is thinking about your thinking. So if you do step A, B, and C, and then after, so it's not just doing the steps. The difference is after doing the steps, you intentionally think about what you did, what you know, what you don't know. You plan what you're going to do differently. You monitor and you evaluate. The difference between how-toing something and becoming skillful is consciously, intentionally thinking about your thinking how you could do it better and how you could improve. So with that, let's do a metacognitive strategy. When we do a metacognitive strategy, all we're doing is trying to intentionally think about our thinking, okay? So when you think about AI, what are like 10 to 15 words, just write them down as fast as you can, that describe AI. And I'm going to go ahead and look in the comments so that I can follow along with it, and you can send those out. So if you have are you thinking of AI automation? Are you thinking of large language models? Are you thinking of tuning and training? Are you thinking of scalability, right? What is AI? And list 10 to 15 words to describe. Now, when I'm looking at the comments, I'm seeing some good ones come through. One of the things that I think is imperative to understand is narrow AI, general AI, and super intelligent AI. Remember, my perspective comes from explaining AI to stakeholders. Narrow AI or weak AI, this is AI that performs a single task, narrow range of tasks, okay? General AI, strong AI, this is the ability to understand, learn, and apply intelligence, and it's critical. It's just like a human reasoning. And then super intelligent AI, this is like every Armageddon movie is about, right? It surpasses human intelligence all across fields, massive creativity. Almost every AI of today is narrow AI. It is AI that performs a single task or a narrow range of tasks. For example, Siri or Alexa, that does voice assistance. Google Maps, navigation. Spam filters, email, right? It does a task. How does this differ from automation? Automation flows a predefined rules. So it's going to perform repetitive tasks without human intervention. It's rule-based, exactly what it does. Think of this as like a vending machine, and you're going to type in the number in a vending machine and it will produce that same result every time. Type in the number, same result. Narrow AI, which is slightly different from automation, but does use elements of automation. Narrow AI is a little different. This is like going into a candy shop and the person behind the counter knows what candy you like, right? It's based off a pattern, decision making, and it's within a specific domain, right? Absolutely uses machine learning, absolutely uses deep learning, but there will be that variation. So automation, vending machine, number, same produce, same result. Narrow AI, generative AI, I go into the candy shop and they know what candy I like, right? It's a little different. It depends on pattern recognition. Once again, we are doing another metacognitive strategy. So everybody take a big deep breath. And I want you to either draw on a paper or on your computer screen, draw a pattern, all right? Before I did trainings like this, I taught kindergarten. So I'm thinking A, B, A, B, A, B pattern. Draw a pattern. All right, you should have a good pattern in mind. And I'm going to blast through a variety of patterns that exist. Numbers, arithmetic, 2, 4, 6, 8, 10. And this is a difference by 2. This is a pattern. Algebraic patterns. These are formulas, right? This is going to be a pattern. Geometric patterns, right? Patterns in illustrations, fraction, polygon, repeating patterns, red, blue, green, red, blue, green. Growing patterns, so very triangular numbers, right? 1, 3, 6, 10, 4, 15. That's a growing pattern. Recursive patterns, usually dependent on a formula. These are where we get those curves. This is the next one is symmetry. Geometry, reflective, mirror, illustration. We see these in things from snowflakes to mathematics. Fractal patterns, similar patterns that repeat at scale. Statistical patterns, right? Norms, linear, regression. And now this is where the kindergarten teacher comes out. Phonological patterns. While I'm explaining linguistic patterns, I would like you to connect using your metacognitive, connect how these linguistic patterns relate to generative AI. Linguistic patterns, the first one is the smallest. This is phonological. So this is similar ending sounds. This is a rhyme. So cat, hat, mat. If you can hear the rhyme, go ahead and put it in the chat. But that rhyme is the at sound, right? This is a alliteration. Phonological is just the sound, right? Peter Piper picked a peck of pickles. If you know what that phonological pattern is, it's p sound. Next, in linguistics, is morphological patterns. This is the difference between redoing and undoing, right? The impact of adding an S, right? So if I say cat versus cats, if I say dog versus dogs, right? So this is trying to put in those patterns there. Syntactical patterns are very similar. This is that subject-verb combination. The pattern that we see most common in English in syntactical patterns is subject, verb, object. So she eats apples. It's really important to understand in syntactical patterns that there's a huge variation between languages, right? So I just highlighted for you a common word order in English, but in syntactical patterns, that word order or that sentence structure will vary. Lexical patterns, this is common phrases. English, this is it's raining cats and dogs, birds of a feather. It's a lexical pattern. Discourse patterns, this is beginning, middle, end. This is topic, sentence, and supporting detail, right? There's a structure to the paragraph. Literary patterns, this is recurring ideas. This is the difference between a poem and a novel, right? Semantic patterns. Patterns of meaning similar or opposite. So this one is group of words. So if I say an animal, well, I mean, semantic patterning is you repeating an animal. So if you want, go ahead in the chat, tell me an animal. Cat is an animal. Dog is an animal. Horse is an animal. Semantic pattern is you can get more specific. So if I say, tell me a sea animal, well, now it's like octopus, it's whale, shark. So semantic patterning is grouping the words, right? Now, when we think of patterns, right, there is a slight difference between pattern recognition versus thinking, okay? And remember, my explanation of this is really to try and get stakeholders to understand your opportunities with implementing generative AI and your risks with implementing generative AI. So if you're explaining that, the difference between pattern recognition versus thinking, like human reasoning and thinking, right? Narrow AI uses pattern recognition to predict what is next. So for example, the pattern is, I eat a cookie every afternoon with a glass of milk, right? I do that every afternoon. That's the pattern. The AI prediction is, I want a cookie this afternoon. What this looks like is, because the pattern is I ate a cookie every day last week, 1:30, offer Joy a cookie. And here's all the natural language ways to offer Joy a cookie. Joy, do you want your favorite cookie? How about a cookie right now? Do you want a cookie? Joy says yes, she loves cookies. We give Joy a cookie. Do you see the pattern? Pattern recognition is what happens when the pattern breaks. So I eat cookies every afternoon with a glass of milk. AI gives me a cookie. Now, if the AI asks me if I want a cookie, I say no. The pattern is people who like cookies also like cake. In the chat, go ahead and tell me, I mean, what's another dessert or pattern? Remember, we talked about semantic patterning, right? So maybe I want a brownie, maybe I want ice cream, right? So when we look at the pattern is, I ate a cookie every day last week. Here's the natural language ways to ask Joy a cookie. Joy, do you want your favorite cookie? How about a cookie right now? Do you want a cookie? And break the pattern. I say no. Because the pattern is that people who like cookies also like cake. It's going to ask me, instead of a cookie, do you want cake? Do you like cake instead? How about some cake? Right? It's using that patterning. You as a person, probably now that you've heard how many cookies I eat, you are automatically thinking. You're using natural reasoning, human cognition, and metacognition. You're thinking, oh my gosh, if Joy eats a cookie every day, her BMI will increase. She needs some vegetables and fiber. Tomorrow, I'm going to offer her a salad instead of a cookie, right? You are thinking, you are human reasoning. So let's get into this pattern. This is what we call manual tuning or training, depending on how intense you do this, but it is simply an A-B pattern. In this example, I just chose offer Joy a cookie one day, B, offer her a salad the next day. A, offer Joy a cookie, B, offer Joy a salad the next day. Do you see, by implementing a simple A-B pattern, we are creating the feeling that our agentic AI solution is using human reasoning, right? This is also where we introduce the concept of multi-agents in narrow AI. In this situation, I have two agents with different data sets and different guardrails and tuning. I have what we'll refer to as salad agent. Its data is fruits, vegetables, micro and macronutrients. The guardrails and tuning are recommend healthy living options. Now I have a second agent. This one's data set is a variety of sweets and desserts. Guardrails and tuning is going to recommend to me preferred treats, right? By implementing an agentic AI where I have two different agents, I have created the sense that this is using human reasoning and thinking, still keeping it within that narrow AI framework, right? The cookie agent, it does a narrow set of tasks. The Salad agent, it does a narrow set of tasks. When I put them together, I create that reasoning feeling. It is important to recognize in pattern recognition versus thinking that you don't know what you don't know. So if the pattern is I eat a cookie every afternoon and the prediction is I want a dessert this afternoon, this is flan. Flan is a delicious dessert, right? The bias, though, is if I have never trained, tuned, or added flan into desserts, it's not in the pattern. It's not there in the data for the AI agent to recommend it to me or to predict it. All right. And so when we're thinking of pattern recognition versus thinking, and if apple pie, I love this. Yes, people are telling me desserts in that chat so I can look them up, because there are other desserts, there are other foods, right, that are not going to be in your training data. And that's where we get into biasness. Taking a deep breath with this concept is I want to talk about the slight difference between large language model training and large language model tuning. Training takes vast amounts of data and computing to create a large language model. All right. Obviously, there's processes that you can speed it up with, but I want you to think of building a car. All right. If you had to build, like if somebody came to you and they were like, I want to build my own large language model. I always feel like they're like coming to me and being like, I want to build my own car in my garage with a hammer and nail, right? The computing power, the labor, the hours to build an efficient large language model is vast. Okay, that's training. Tuning is the mechanic. All right. I love my car. It's great. It's reliable. I still need to take it to the mechanic. I customized it slightly for myself to make it more enjoyable and all of those things. That's tuning. Right? So when you're thinking of large language models, when somebody uses the word training, I want you to think of building the car engine in the factory. That's the amount of labor required. When someone says tuning, I want you to think of a mechanic being like, car's already built. We're just going to do a little tuning so that you enjoy it the best. All right. Large language models. Looking at a large language model with the concept of how much labor is required, as I just love food. I love food, all right? So thinking of the beginning of a large language model, like a baby learning to eat a variety of foods, all right? We're going to feed, when we first start it, we're going to feed the baby like formula and mushy foods and little foods. And as the baby matures, we'll introduce more complex foods. So this is me and this is my husband. We're adorable. But what I want you to think about is that we are two mature adults. Okay. So when I was younger, when I was a baby, I was learning to eat so many foods, right? And then when I was mature, like a large language model has to be mature. So when I was mature, then large language models have a relationship with RAG and CAG. All right. Just the same idea as with me meeting my husband as a large language model. I was mature. And then I formed a relationship with RAG and CAG. Now, as any good relationship goes, obviously those start to blend, right? But really understanding how they interact is helpful. So let's talk a little bit about RAG, CAG, and additional ways to improve output. Whenever I think of RAG, I think of like just consuming vast amounts. My husband, I enjoy food. We got married. My husband is a connoisseur of food. And so we go to this friend's house and they've invited us to a luau. Specifically, they've invited us to a Tongan luau. And we are eating so much new foods, like just plates and plates and plates of foods I've never seen. And in this analogy, right, it's just an analogy. In this analogy, that's like RAG, right? Just vast amounts of data to consume, all right? Talking a little bit about how that differs from CAG. CAG is when when my husband found out that I'd never tasted real wasabi. As mentioned, I live in the United States and in the central part of the United States. Because of that, we don't have great sushi. I know. It is actually its own tragedy. But wasabi in the United States is mostly green dyed horseradish. And so my husband, he was like, oh my gosh, we got to have you try real wasabi. We went to a specific restaurant in our area. We ordered a specific menu. We got that single dish, and it had little shark skin, and they brought out the root and they grated the wasabi from it. This is very specific, right? Where I want you to understand the difference between RAG and CAG is RAG is like going to the luau and eating plates, tons of new food consumption. CAG in this analogy is getting a specific information, specific data, and just a single item. All right. Now, as you start to get more skillful, you will start to understand when it is appropriate to implement a RAG solution and when it is more appropriate to implement a CAG solution. Additionally, with improving output is accuracy. The first time I tried fufu, I was in college. It was a friend of a friend. She was dating an African man and wanted to impress him. So we all went over. She made some sort of stew and fufu, and it was not good. And I don't mean that. It was just like, I was like, man, I can't, it's not good. Years later, I went to an actual Caribbean restaurant, and they served like this, it was like this succulent grilled chicken in a sauce with fufu on the side. And the fufu was, so good. If you're consuming, all right, my first exposure to fufu was bad quality, all right? It was a bad quality fufu. My second exposure to fufu was high quality. Definitely improved how I view the food. Keeping that in mind, right, is really thinking not only about consuming more, but the impact of consuming quality. We talked about good old flan. If flan's not listed in your data set, it will hallucinate, right? And you know what? The world should know more about flan. The key word in generative AI is generate. We cannot make something out of nothing. Garbage in, garbage out. Bias in your data, bias out in your output. Bad quality data, bad quality output. Pattern recognition. I love it. Obviously, obviously, deep learning is a well-established. Obviously, it's more like complex than cookies, cake, and flan. But if you can explain to your stakeholders at the beginning of implementing an agentic AI project the significance of pattern recognition, throughout the implementation, everyone on the project has a better understanding of, maybe we have bad data. That's why we're not getting the output we want. Implementation. All right. Implementation is, I want you to just kind of think to yourself, this is where I'm going to start featuring some of the projects that I have specifically worked on. All right. This is my favorite part of, I try to kind of almost rush through that original content to get to implementation because I really want to spend some time. I've been implementing AI for 3 to 4 years as a project manager. So let's talk about what that looks like. I want you to list, you can send it to me in the chat, but I want you to list your own best practice standards for strategic AI projects. So some of the things that I think of is data security. I think of that so many times in my life that it comes up a lot. What are other, put it in the chat there, what are other best practice standards for strategic AI implementation, right? If you are thinking, all right, I'm the developer on here, I'm the project manager, what do we need to prioritize? Well, these are the things that I have learned. First is what you're selling with AI is information, all right? That can be coming from data sets, that can be coming from knowledge shares, Q&A. You are selling information. So I want you to think of a grocery store, because what grocery stores sell is produce, right? And I want you to walk into the grocery store and I want you to see where they have all of the bananas, and I want you to see where they have all of the vegetables. And just like this picture depicts, right, is the cauliflower is organized in one section and the tomatoes are in another section. And why I'm starting here is because if what you are selling is produce in your grocery store, you need people to walk through the aisles and easily get the produce that they want. I think that matters to your store. If what you are selling in AI is information and data, you need to take the time to think of how you are presenting and organizing your information and data so that the user can walk down and select, easily pick the information and data that they want, right? This is putting AI, generative AI projects into data lineage. With this analogy of the output being the grocery store shelving and the shopper experience. How are people consuming in the grocery store the produce? But in your case, how are they consuming the information? I grew up on a dairy farm, youngest of 9. Farming is labor intensive, right? So if I have a grocery store and what I sell is produce, I need to work with the farmers to have high quality produce. I want to sell fresh apples. I want to sell produce that's in season, right? It's going to take time to cultivate, to maintain. If you've ever had any level of farming experience, you respect how much labor farming requires. Now, in this analogy, let's take that same respect for the labor required for farming and put it on data farms, all right? If you want good information in your store, if you want people to access quality data, you have to cultivate, you have to harvest, you have to maintain, you have to have good data that you're farming. All right. That's again putting generative AI projects into data lineage. Right? We have our grocery store output, we have our farming and harvesting of our data here. And everything in the middle is what I'm going to refer to as explainability. Essentially, how did we get the apple from the tree into the grocery store? Right? We have trucks, we have people picking it, we have shipments. That's explainability. How do you develop trust when you're selling data is explainability. You've got to be able to tell people, how did I get the information from here onto the shelves? And that process is called explainability, and it is pivotal that you have clear explainability to develop trust in your outputs. Data lineage, ensuring that you understand generative AI projects as part of data lineage, because in this next section, I will tell you, I have implemented AI projects for several years. I comprehend there are more elements. To keep up kind of with the nature of this presentation, I'm going to share those experiences, and I want you to keep it in those 3 areas. I want you to think of risks or opportunities in your data. I want you to think of risks or opportunities in the output. And then I want you to think of risks or opportunity in explainability. Right now, let me tell you what this project was. This project was insurance first notice of loss. First, I'm going to define what the first notice of loss is. First notice of loss is I'm driving my car, here's the stoplight, I drive up here and another car hits me, it rear ends me, right? The phone call that I make to the insurance company, where I say, insurance company, I am insured. I was driving my Toyota. I was on Main Street. I got rear-ended. That phone call is called a first notice of loss. So with this insurance company, a major Southwest insurance company in the United States, is they wanted to implement a generative AI solution to streamline first notice of loss. All right. It is important because they did need 2 agents, 1 agent for English and 1 agent for Spanish. We get this project implemented and we go into our first phase of testing. In the first phase of testing, with this project, we had really good data. It was a well-established insurance company. They had clear procedures. We were able to implement those in. We had explainability because of the quality of their data. It was very easy to see how we were generating these outputs. Now let's talk about output. The first red flag with this project was an output. When somebody called in for a first notice of loss, and if someone had passed away, all right, I want you to truly think of humans interacting with an agentic AI solution. And you have just been in a car crash where someone passed away in the car accident, and you need to call the insurance company. Let's talk intentionally about the kind of this ethical reasoning with that, as well as in transparency, the ROI. If somebody passed away, if there was a massive injury, such as the loss of a limb or a severe impact, right? On the first notice of loss, if we sent that person directly to an agent, it was not a good experience. All right. It, like, no matter how, because it's based on that pattern recognition, it is like, please tell me about the death on Main Street. Oh, not, Now, why do I always lead with a story when I'm talking about what I've learned and what I haven't learned implementing AI. And I lead with this one because I think that there's this false belief that we can just put AI everywhere and it's going to solve our problems. If you look at this strategically, if I'm implementing AI for my first notice of a loss for that teenager who ran into the mailbox, right? If I'm implementing my AI agent for first notice of loss for, like, you know, fender benders, if I'm implementing it for people who got into, like, who, I don't know, I implement it for these general implementations. My human agents have much more time, intentionally and strategically, to spend on the phone with somebody who maybe they lost a leg in the car accident. So instead of my live agents needing to rush through them and just get them done, they can spend a little more time talking through with them on that first notice of loss. Implementing agentic AI solutions is not implementing it everywhere. It is truly implementing it strategically. So let's talk about the next one. Nuclear facility training. Okay, shake it out. Remember, we're thinking of data. Where is our data coming from? The impact of our output and securing explainability. A Northwest nuclear facility company wanted an AI solution to scan their manuals and answer on-site questions for new employees. So pretty straightforward implementation. I am a nuclear facility engineer. I take the company iPad, I go to the nuclear facility location, and I ask a question, right? I'm at this location, I am working on this specific machine, and I need to help going through the 5 required steps, right? Now with this, I want you to see that project. So you go to the site, you ask it this question. And this was fairly easy because of the quality of manuals, right? So in short, if you go to location B, my data set is ensuring that I'm directing you to the right manual, right? Using that manual, you're at location B, you're at equipment B. We're using all the B manuals to answer your questions, right? This was fairly straightforward until we had a red flag with data. So let's talk about that. Manuals are wonderful. They are not the same as talking to the human expert. So once we got this project into training, we're doing our testing and things like that. Obviously, with a nuclear facility, you want to do a lot of testing. We get into testing, and we realized that the manuals were like accurate-ish, but the experts would then jump in and be like, yeah, you do this and then you have to do A, B, and C, right? This project actually turned into a manual update project, right? Where we would have the nuclear physicists testing it and then being like, oh yeah, this aligns, this is best practice, this is what we do. And then being like, oof, that line right there, I'm not sure. That's why you need explainability. And we'd be like, oh, you're not sure. It came from, paragraph 5 of this manual. And then they were like, oh yeah, that's the outdated manual. Delete that outdated manual, update it with the new manual, right? That's why explainability is so important. All right, let's go into this next one. The North American Lottery. All right, so the North American Lottery, they needed to have specific answers for specific games, right? So with this project implementation, this was a website chatbot utilizing AI. I am playing on the lottery. I want to know who won the jackpot in Oklahoma. Totally random state. With this one, what was really helpful, total green flag, is how separate the data was, right? So here are the laws for the lottery for each different location. Here are the rules for each different game, right? And then here is the updated winners. Here are the next games that you can play. Why this is really important is I want you to kind of see how important it was in our data strategy that we had consistent updates, right? So with that one, when we implemented the North American Lottery, what we had to schedule was scheduled updates of data, right? So making sure that the data we were consuming was accurate to the updated website, to the updated games. Making sure that if there was a change in the law, right, with like maybe you needed to bring your driver's license to collect or things like that, but those were all updated. So imperative with this one was implementing a data sync strategy, right? So that the generated output was accurate to the timestamp. Celebrity profiles. This company wanted to implement, it was a PR company where fans could have live chats with celebrities. The answers would be AI generated based on celebrity profiles written by the PR team. So this is really important to understand that these chat conversations were not random, right? The chat conversations were based on the PR team produced like it was like hundreds of pages, but they produced hundreds of pages of like an approved PR profile. And then when the user typed in questions, it could generate a response as if you were talking to that celebrity based off of the approved profile. This one had another, remember we're thinking data, output, and explainability, the impact of those. This one had a huge output impact with guardrails. as soon as we started implementing celebrity profiles, getting the project into the initial phase of testing, tons of sexual content, right? And absolutely celebrities uncomfortable with that and absolutely prioritizing guardrails, right? Why I bring this project up is I think that sometimes we believe guardrails as an afterthought, right? I think it's really important when you're strategically implementing AI that you think of the end user and the actual impacts of humans. Humans are a little crazy, and how you need to implement guardrails with the awareness of just human interaction. This one required a ton of sexual content guardrails to ensure that it aligned with not only the PR team's expectations, but also so that it aligned with the celebrities' expectations. Banking was similar. This one was about guardrails. So, international project, we implemented a generative AI chatbot to support citizens with their banking needs in South America. And because we didn't follow the IP address, it was a ton of high schoolers. So a whole wave of high schoolers found out about this generative AI chatbot, and then they asked it so many crude questions that you can imagine any high schooler would. Now, I laugh because this is funny, but I want you to think of a business and an ROI, and I want you to imagine if you are a business owner, you own the bank, and you are getting literally hundreds of thousands of crude questions on your chatbot, how expensive that is, right? Each generation usually has a token. Each token has a cost. Each cost adds up. So if you have high schoolers asking your chatbot thousands of crude questions a day, it was expensive. So that one was, so remember we have our data that we have to be conscious of, we have explainability that we have to be conscious of, and we have output. This one was another guardrail in that kind of space between output and explainability, where once we actually used the high schoolers' own comments, implemented a little RAG and CAG strategy, and started to just generate. As soon as you make it not fun, people stop, right? So as soon as you catch on to those comments and then you state something not fun where you're like stop utilizing that, you may only ask, like, I am only directed to answer questions related to banking needs. It's no fun, and people naturally slow down, right? But yeah, so once again, when you're implementing, thinking of your data, explainability, and your output, how are users actually going to be interacting with your agentic AI solution? Urology Southwest Clinic. This clinic wanted a patient to easily schedule urology appointments with the correct expert based on their medical history and patient relationship. It is important to know that this was a voice agent as well, a voice agent, because of our data set. I am not a urologist, and the data that we were using to schedule urology appointments was medical data. We did have to do a lot of tuning on this project. Remember, training is building the car by scratch, right? You're building it from the beginning. Tuning is being like, hey, here's our standard LLM. We don't have urology terms. Let's tune, let's be the mechanic, right? Let's make some customization. Let's add those medical terms to our large language model. And that was critical in this project, right? So we definitely had to do a lot of tuning. We interviewed several doctors to make sure that we were pronouncing the medical terms correctly and add that into the tuning for the large language model. Additionally, we also had to add the doctor's names and the clinic locations, right? Anytime you are using a large language model, those medical terms or specific demographic terms, you're going to want to tune for them. You also really will need to tune for any personal nouns. So for example, if you know the clinic street address, that needs to get tuned. If you know the doctor's names, that needs to get added to the tuning, right? So I want you to think of your large language model as very basic linguistic, right? It's mature, but it has a relationship with RAG and CAG where we're tuning it to add those specific terms that relate to that specific project. So that's that data, explainability, and output. Tons of work on data to make sure this project was successful. University student enrollment. The university sought to support students, particularly first-generation students and those whose first language is not English. The project expanded into additional resources for staff, potential hires, professors, and parents. This project, back to that idea of data, explainability, and output needed a translation element. I always encourage, let's talk about what this looks like. If your data is in English, right, and your output needs translation, you do need an explainability. You do need to explain to your agent that data is English, output is translation, right? Because that will help your translation to be smoother, right? Knowing that kind of best practice, knowing that, as good as we are at translation, just kind of flagging that. Often I like to put in a little like asterisk and just be like, hey, this is a translated AI agent. Please be aware that some translation is, there might be some translation error, right? That just gives people a little bit of a training the user best experience. But with this university enrollment, we implemented a translation element. We really depended on that explainability, clarifying to the agent that the university's data was English, and that enabled us to get better translation on the output. Company HR. The company wanted an AI solution. They chose to start with their HR. And I think every company should keep this in mind. HR departments have great sets of data. Remember, we're thinking data, output, and explainability. If you want to implement a good AI project, you're going to start with your department that has really clear data, well-defined procedures, and that will enable you to make quick workflows, access quality data, access accurate data, right? And so if you're like, ooh, I don't even know where to start, yeah, usually HR departments are a great place to start. Most HR departments have those critical elements in their data. The data is accurate and they have clear procedures, right? That's exactly what happened with this use case. Large international company, they wanted an HR solution. We were able to access their data by different countries. We were able to access their HR data by different professions, right? So are you a contractor? Are you a full-time employee, right? Those were all different. And we were able to use that robust data set to get really good generative AI outputs. National sports retail, data, output, and explainability. This one was a combination of that output to the data set. So essentially they wanted to add a generative AI solution onto their company's website where if somebody was purchasing a product, they could ask about the athletic use, right? So extreme sports, rock climbing, how should I use this product, right? What we found was identified risks. And this one actually did get escalated to a legal team because of those. So if I am, buying a tent for this first time, this was the use case. They said, oh, hey, I'm buying a tent. We're going to go camping in the snow-covered mountains. I want to put a heater in the tent. right? And if you put a heater in a plastic tent, you will melt the tent and potentially start a fire with you trapped inside the tent. That's not good. We don't want to do that. And so what we had to train for is what's referred to as a non-answer. All right. So when somebody asks a question that's very specific like that, right, where it's like, hey, I'm camping in the snow-covered mountains and I want to put a heater in my tent, right? It goes back to the agent and looks at the data. Now, if that specific question is not in the data, the safest answer is to politely respond that I do not have a good answer for your question, right? Now, later, you as a team can look at your explainability and you can highlight all of the questions that the agent was like, hey, I don't have enough data on that. And you can add the data, you can update the data, you can change the data so that in the future it can answer that, no, you should not put a heater in your tent, right? But you do want what's called the non-answer. So just very clearly, if people ask questions to your agent and those agents, you don't have good data on it, making sure that it's telling people, I cannot answer that question, is safe, because we don't want people melting themselves in their tents. That's just how it goes, right? Producing a non-answer. Retail inventory cleanup. So this was a steel manufacturer. They had nearly 30 years of inventory. All right. This was a massive steel manufacturer that did products for specifically oil rigs. They chose a very expensive LLM initially. I see this a lot. Different large language models produce different quality. Some large language models are higher quality, some are lower quality, some are more expensive, some are less expensive, right? This company essentially initially chose a very expensive large language model. Project was fairly straightforward. We upload data, we generate some responses, use explainability to clean up the inventory. After about their third iteration, right, we realized that we were like their data was clean enough and we moved to a less expensive large language model. I do want to talk about this a little as far as a PM strategy. A lot of times, by the time somebody's reached you, they have already, there's just this desire to have the best, right? And they're really worried about the large language model not being perfect. And so intentionally working with a project or a solution where you can switch large language models enables better output, right? So utilizing and intentionally thinking, how could I switch large language models if I need to? That's going to impact, in this case, it impacted the cost, right? In other cases, it's going to impact the output. And in some cases, it will impact actually legality. So now that we are starting to enter a more solidified, like we have rules, right? There are, like within the US, if you're working with certain government agencies, you cannot legally use certain large language models, right? So everyone take a few minutes when you are planning a project to research the impact of the large language model. And I always recommend having the ability to easily switch large language models mid-project if you need. Whew. I love that section. It is so fun to highlight projects, highlight how they go, how they fail, how they succeed. I love it. I want you to take a moment, though, and write down your definition of an expert. I have given you kind of at the first half, I gave you a clear, this is how I explain simply agentic AI to stakeholders. We've spent the last majority of this presentation where I just highlighted projects and told you what went well and what didn't. And now, what is the expert? When you are working with agentic AI, you want a spectrum of experts. I always recommend having a content expert. This is somebody who reviews the output. This is somebody who aligns to ensure it's with real world knowledge. I want you to think of the project I highlighted when we worked on the nuclear facility and how we needed a nuclear physicist to come in and review the outputs. That is your content expert. And every generative AI project, in my opinion, especially secured environments, should have a content expert, someone who's really making sure that this aligns. Developer expertise. This is your technical expert. This is usually someone who's a backend developer or making your website. But this is the person who's developing it. And then, like I said, I feel like this is a spectrum. There's everyone in between. I'm a little bit more of the spectrum technology expert. I'm not a developer, right? I actually don't do the final development or implementation. And I know nothing about nuclear physicists. But you do need technology experts that go in between those two extremes so that you can get projects across the finish line. Utilize your experts and find them. Thank you. I am just delighted that I got to make this presentation for you all, as well as if you have like any questions, I can follow the comments in the chat, or if you want to like ask me anything, I'd love to kind of make sure that I'm presenting there for you. I'm going to move my screen back to here, but thank you.
Wow. I'm in all joy with what you have just set together, put together. Uh, I don't know how much time did you spend on this? I'm really wondering. Was it something that came out of you, like a simple, how can I say, a simple way to explain your thesis here, or you spent a lot of time to do this? I really want to understand your way of your process, if I may.
You are looking at 4 years later. So when I first started to be a PM, the difference between what stakeholders wanted and the gap between what my developers told me was possible was huge, right?
Okay.
And so I started asking my developers what actually is AI. And then they started to be like, well, it's this and this. And then we just wrote a lot of analogies, right? A lot of food analogies, a lot of like the grocery store analogy to explain what that is.
Yes, yes, I saw that. We have a question whether you will have the first spectrum slide. Do you have the first spectrum slide?
Yeah,
User is asking.
yeah, I do have all of the different slides there, so I can make sure to get those ones. I don't know how to get them out. Let me see.
Uh, you can send them to me, and
Oh,
I can share them with our community in YouTube.
perfect.
Whatever is easier for you.
Yeah, I'll get you all of those. I'm putting it in my little notebook right now, so you'll get it to me.
Sure.
I'll get it to you after.
Okay, thank you.
Mm-hmm.
Wow, what an amazing session. Sometimes we are very taken by our technicalities, but this was a good, how can I say, wake up call for me, listening to your way of analyzing the situation, the ecosystem, and how we as humans should, and it's better actually to take this step and uh, use the analogies, take a step back, and understand AI from another perspective. I really liked also the last part where you said about government and the flexibility to switch language models when needed and if needed. Very important stuff. I'm going to watch this again, of course, and everyone here in Azure AI Connect. I hope you really enjoyed Joy. Thank you so much for joining such an early time in your location. We are so honored to have you, and hopefully, we will see you again in another event. Maybe we can meet also in person. From the bottom of my heart, thank you, Joy, for coming today.
Thank
Have
you,
a
sir.
great one.
Thank you, everyone.
Bye bye. So that was Joy Curtis with a very, very interesting session. I really liked it, and yet I have to rewatch it so everyone can, of course, rewatch everything in our YouTube channel, which is currently streaming, and it's going to be there for the rest of the channel's life cycle. I'm going to switch to the video as usual. I don't see our speaker, our final speaker. Maybe it's a little bit early, but yeah, we can take a break. We can get a drink or something, and we will be right back. Regarding the content from our speakers, just like Todd asked here, I will be responsible for collecting content that the speakers would like to also share, of course, and post everything in the YouTube channel, in LinkedIn, and probably could be some announcements in our main website, which is, as you know, let me show you. You may have seen that already, but it's this one. So probably we're going to have some, after session summary in this website, containing information about the content, about speakers. Maybe I will implement something like a chat so we can have a quick discussion about getting the content on. You may want to ask some questions at a later time. It will be alive probably 1 month after uh, uh, the finalization of this event, Azure AI Connect 2026. Thank you everyone for being here tonight. 5 hours for 5 days each afternoon. It's a very interesting, exciting, and challenging series, but I really liked it, and I was able to make it true. And of course, it is true and alive thanks to you, the participants, the speakers, and all the enthusiasts that power our communities. Everything is done for the community, by the community, and I love to be just a little part of this with everyone else. I'm Konstantinos, I'm your host, Azure AI Connect Day 1, and we're moving on to the final presentation, the final session. Hopefully, it will be here in a few. Let me play our video, and if you have any questions, just drop them in the chat. If I may answer it, I will answer immediately. Otherwise, as I told you, I will explain how we will get more answers in case we cannot get them immediately right now or today. So, Azure AI Connect 2026, we are moving forward to the final session for today. Of course, we're going to be with you in the next 5 days, and we have the pleasure to have with us Himanshu Goyal. I'm going to add Himanshu on the stage, and I hope I pronounce your name correctly, my friend. Hello and welcome.
Yes. Hi, how are you?
Where are you calling from, if I may?
Yeah, I'm calling from Philadelphia, USA.
Okay, great. So it's early or late there?
It's
It's
about
early in
it's
the
about
morning.
yeah, it's afternoon 2:30 p.m. I just wrapped up my meeting after lunch, and yeah, it's a good
Okay,
time
okay,
to present.
okay. Thank you so much, Himanshu, for joining us in Azure AI Connect. It's been really an honor to have you in this setup for 2026. Um, Let me review a little bit your session here.
Sure.
And, so we have, yes, civic agents, the rise of AI in modern public service. Quite an untouchable theme, right? People steer away from public services and the AI because it looks difficult, it looks challenging, but you're going to touch it today and you're going to explain us probably how to do it. So the stage is yours, my friend.
Sure. Thank you, understand. Thank you, and thank you for giving me an opportunity today. And let me share my screen. This is my first time using this platform, so please bear with me and let me know if you share this with two monitors. Screen. All right. Let me know if you see my screen now. All right.
Absolutely.
Great. Super. Yeah. Thank you. So, yeah, as Constantine mentioned, this is the session for Civic Agent, the rise of AI in modern public service. And we see quite a bit of resistance in public service for not just from AI implementation, but in the cloud technology in general, moving forward with the modern technology. But on the other hand, we see some outliers where strong leaders are making sure that they adopt the latest technology. So today we're going to cover some few of the use cases as well. Um, before that, I will give a quick introduction and background on myself. I'm Himanshu Goyal. I'm founder and CEO for a company called Ignatius, and we have a dedicated public service entity called tech4gov.ai, which I launched last year in January after working with public service for over 10 years. And quick QR code for my LinkedIn if you would anybody want to connect. My introduction. I got introduction to AI maybe about 2009 to 2011 time frame when we were working upon this platform called Scout Photo. And what Scout Photo, and this is a TechCrunch news article from 2013, where Scout Photo got funded on a pitch night. But what Scout Photo was that I built a platform where you could track the faces, and based on the different facial points, you can map the face along with the bib number. And this is a running shot from a marathon race. And then now, if you know your bib number, you can enter that. Wherever your bib number was not visible, that picture would also come because now your face is tracking with your bib number. Little I knew that time that this is called visual intelligence now. So that's the quick background when I was introduced to AI. But before moving forward, I would like to ask this question: that how many of you feel that AI is an existential threat or an exponential opportunity? Any questions? I'm not sure if the polling is doable in this platform, but usually when I ask this question and I see that different faces come out in the conference hall or in the session, that some of us thinks that is an existential threat, some of us think that is an exponential opportunity. I asked the same question to Chat GPT and Microsoft Copilot, and this is what the answer I got. That yes. So reason being that AI is nothing but the reflection of what you're trying to build. You could build a bot or a mechanism to hack a credit card, or you could actually have a meaningful application which can perform certain tasks for you. Before moving on the public service, I have a quick poll. what do you think about this crossroad? Who should go first? Is it going to be a fire engine or a presidential car, ambulance or police car? And during this, I've done some of these surveys over my LinkedIn, also over WhatsApp, and to my extended family, and we always get this mixed responses. And with the short notice, let me share what it does. So the survey results which came out was primarily fire engine 33%, ambulance 50%, passenger car, and police car. And what I noticed was it's more which where geographically where you are located. Some of my friends in Europe had some very specific answers. Some of my family members in South Asia had a different answer. But to the most part, ambulance came out as a common theme. Not because ambulance should go first or had any preference to add to it, but in some shape or form, we all are connected emotionally with a medical emergency. But if you notice this picture which I shared, it has no emergency lights on. So this is a crossroad and there are no lights on. And but since we a human when noticing it just got emotionally connected with ambulance or medical emergency and picked that option. But when I asked the same question to Copilot, I got the answer that first come first serve, meaning even the chat GPT similar answer that whichever vehicle came first to the cross section would be the one going ahead. So what it tells us, it tells us that AI is still looking into a logical way of finding the answer, not adding an emotional context to it. Moving forward with Copilot, and so that's where we will see today that how these technologies, Copilot, Microsoft Azure AI Foundry, can help building this public service more modern, utilizing some of these AI models. So first and foremost, introduction to Microsoft Copilot. Just wanted to give a quick background that, okay, there are three different Copilot which exist in terms of what you could do with Copilot Studio. There is you can build, customize Copilot agents. You can build some agent with a specific guardrails in a limited fashion. Then there's a Microsoft 365 Copilot, which integrates with your Microsoft 365 ecosystem. Then there is a Microsoft Copilot, which is where you could have some of the agent itself, and you can connect with your perform certain searches, perform certain NLP driven workflow automation. Please feel free to raise hand or ask questions if there is any. All right, so this is evolution of Copilot. This is another one where I get a lot of these answers that Copilot was invented in 2023 or 2022. Just for the record, Copilot came to existence back in the first version of Copilot came to existence back in 2015, and it was not integrated with any sort of large language model, and Copilot adoption and branding started till 2019. It was evolving. You will see there's more of an FAQ driven answers. Microsoft Word, Microsoft Office had it, and eventually starting 2021 when the GitHub Copilot was launched, it became more and more of NLP driven assistance for Microsoft ecosystem. With OpenAI investment from Microsoft, that led it to a foundation of Bing Chat, where you had this Copilot, which became a first consumer-facing OpenAI GPT-4 model. And hence, since then, that just continued to evolve. And here comes August of 2025, when GPT-5 was launched, and 2026, early this year, there is now Copilot has some agentic capabilities where the orchestration can happen. You can define multiple tasks. You can integrate different line of business applications to it. That being said, I'll give a quick background on what is RAG and what is agentic RAG before moving on to very specific use cases where we can go a little deep dive and review how public services are adopting these agents. So first we go with RAG. It seems that thing of a past now. A lot of people know. I just want to give a quick background that RAG is a retrieval augmented generation, meaning a user asks a specific ask the question. LLM is smart search, very similar to how Google search works. It will go back to the data, it query, it brings the relevant information back. Instead of giving you a list of keyword-driven URLs, you are now getting a very relevant information. And this LLM question plus the relevant information brings you to the enriched answer. And that is, this answer is, this whole process of building this answer is what retrieval augmented generation is. And this is the RAG agents is the reason why artificial intelligence became a discussion of a dining room from a boardroom. AI existed in past. AI existed for many, many decades now. Weather department is using it. Aviation has used it. But now this is where you see more and more, due to the RAG agent, this becoming a talk of a town. I see some raised hands here. I'm not sure if, okay. All right, I go back to chat. All right, so now what is agentic chat? So agentic RAG. So now to make it agentic, what happens is that user is still asking a question. So it's more of a user input or a topic which has been entered. Now LLM search, instead of just putting that topic and going into the different query and bringing the relevant information from the data lake, it breaks down into multiple tasks, which is where you connect with different type of different line of business applications, or you are connecting through an API or different tool set to build together this current build together the response. And it could have certain workflows, it could have certain different activities which needs to be performed. But after performing those activities, connecting with different APIs, it brings the response back to you. And that is where, and when it brings the response back, it validates that the answer is correct. So that is nothing but how you perform an agentic RAG. What are civic agents? So now these civic agents are not just a RAG agent. These civic agents, yes, does some agentic RAG implementation, but are your digital teammates. These are the teammates who understands how certain tasks can be done. To the most part, these are the repeatable tasks which has been performed by a lot of public service workforce, which can be now augmented utilizing some AI technology. Automated permit approvals, checking some compliance checking for these permit applications, and handling citizen queries 24/7. This is a very good use case for a RAG agent where a citizen services team can actually provide communication back to citizens on 24/7 basis. Case management, pothole reporting, tree fell. I mean, these are some of the normal use cases which we see quite a bit, where instant responses are required. And to the most part, public services sometimes not able to do that. And that's where these RAG agents can help. And I'll show you some of the examples going forward where how these agentic RAG is elevating even those queries. So why should you care? Now, this is not something which is only a public service employee should care for. These are something which everybody deals with the slow processes. We as a part of the ecosystem, as a constituent, also need to have a better a public care. And it's not always a public sector or a problem. It is a human problem. Like if it affects all the constituents and citizens. And how these problems can be solved with AI. Many times we see people working in public service come back with the workload complaints, the lack of time and the amount of workload exists, those repetitive questions being asked, those follow-up which require multiple stage of workflow approvals. So those are the things which delays the overall public service. Now, how are we going to resolve this? So we understand some of the problem statements. We understand some of the capabilities of RAG and agentic RAG. We understand what are the three different ecosystem inside Copilot. But how are we going to resolve these problems utilizing Copilot or from Microsoft AI Foundry? So first and foremost, the Copilot agent, as we see, it is where user submits a question and receives a response back. It talks to a large language model, and this is pretty very straightforward how a Copilot works currently. Now you can have a knowledge agent which can now connect with your specific RAG model, talking to a website, which can be a public facing website or a knowledge source or a SharePoint document library. So now you are limiting that large language model knowledge with a website. So this particular interface can get you the knowledge only from that particular website. Now, putting a governance control on this, this is like where Microsoft Purview can help, and providing a guardrails to the existing LLM and defining the source as website still can become a knowledge agent where you have a guardrails being implemented. Now imagine in this current situation, if we can get a custom data tools, for example, not really just talking about a website or a SQL data source. Now you can add multiple custom data source. When you work upon these custom data source, before we go forward, let me open Copilot Studio. Okay. So you can add custom data sources. Now, these custom data sources could be a line of business app, which is required for local government to function. It could be a finance app. It could be a permit application. It can be your case management tracking system, or it could be your public works application where you manage all of the construction vehicles and stuff. So any of these custom application can be part of this. Just opening a Copilot Studio so that I can show you how these agents can be built in real time. So while we are waiting for this Copilot Studio to open, now you added a custom data source, which is where it can help you build an agent which is talking to this custom data source. That can be your any internal application. And if the agent, while we're setting up the agent, if we can establish a memory where you can actually store the past actions being taken, that could elevate this agent in terms of becoming a full-blown autonomous agent for you. Now, these tools, which are the custom tools, can be added, and I'm just did the open request, and let me show you an agent which we're going to build quickly in ChatGPT. Copilot. So this is Copilot Studio, and I'll show you quickly how to build a knowledge agent out of it. We'll take a website for Philadelphia, since it's my home city, Philadelphia.gov. Okay, skip. So what we will do is we build an agent, which this is a Copilot Studio, and it create a blank agent. And I'll provide this agent a knowledge source for Phila.gov, which happens to be Philadelphia, City of Philadelphia website. And this agent would talk to City of Philadelphia, and we ask certain questions, and we'll see how different the answers we get based on the information which we seek, instead of doing a Google search or a search on the website. So we start this, add a knowledge. In this case, we add public website. We make it Phila.gov. All the source exists. Add to agent. It will take few seconds to get the the crawling to be complete, and I made it enable your search all public website disabled. So I'm restricting the knowledge to filler.gov only. Now I ask this question first. Let's ask this question: how to get a parking permit on City of Philadelphia website? So I say how to get a parking permit. Get electrical permit, tenant permit services. So I'm asking for a parking permit. I'm getting all of these different URLs because this is a search which is being performed in traditional way, where it is looking for all the words which I have typed in the search box and mapping with the keywords. Okay. Tenant, building permit, plumbing permit is not giving me parking permit. It's giving me all sort of different permit applications. Okay. Now I ask here, same question. How do I get a parking permit? As you see that it took about 1.76 seconds to build this response back. It looked into, these are the reference sources where it looked into. So same site, it doesn't have any other data source to check on. And the response I got, since I asked very specific question, how do I get a parking permit? I got a response back that types of parking permit are available: residential permit, disabled parking zone, application process, where to apply. And on top of that, a follow-through question that you want to apply for a parking permit, applying for a residential parking permit. And now I can build the conversation around it. So this is where you can, and now I'm getting directly to the page where I can apply. But when I'm searching the same content on the website of City of Philadelphia, I'm not getting the similar response back. I go back to deck. So this is the where we could build some of these agents which can be easily deployable. It can act as a 24/7 citizen service and can build a meaningful conversation around the data which is already in public domain. So I am not creating a new data source for it. I am not harmonizing any existing data. I'm just building a knowledge agent on top of what the website already has to offer. So if your content on your website is correct, then this agent will perform well. So now when we go to the next step, so what we have seen, what we saw so far, that RAG, agentic RAG, we built the RAG agent. We saw how Copilot can perform as a knowledge agent. And we have established a memory from this architecture. Now, if you go to the next step, that is where you want to build certain autonomous agents, which can perform a meaningful task for you and keep human in the loop. Now, to build that, instead of having these custom data source sitting in a box down here, what it has done, and you are interacting with this data, and everything is becoming part of this large language model, and the user is prompting and you're getting a response back. So far we're still into that notion where, yes, the data is in multiple places, but you are getting information back through large language model. In the next stage, what happens is that instead of going with the custom data source, you are building an agent which sits on top of your specific source. So in this scenario, it's a Salesforce system, which is where you are managing all your constituents' data. And this RAG agent is talking to Salesforce. So now you have an agent which sits on the Salesforce. Same thing, Dynamics 365, because that's where you are maintaining your internal ERP system, finance, and operations. Same thing for SharePoint. Now here you have your knowledge, your SOPs, and you are building an SOP library which is sitting in SharePoint. Now this agent is not just retrieving information and putting everything in large language model, but based on the user interaction, you can actually submit the responses back to the source. And that's where the magic happens now. Because so imagine a use case of a pothole reporting. You saw a pothole, you took a picture, you uploaded on the website, and the county or city website had information where you can submit the case. And as soon as case gets submitted, this case gets reviewed inside this model, and model understand that this is for DPW, and Department of Public Works needs to work upon it. So it sends the request to Department of Public Works. DPW goes in and checks that, okay, this new work order is being created, and now I have to submit, or I have to work upon this work order to fix the pothole. DPW sends the vehicle there, the contractor fills it and submits the information back that this is the latest picture, it has been fixed. The case get updated, and the originator, who the constituent who actually reported the case, gets informed back that the pothole is being fixed. So this is where the complete autonomous agent comes in a mix, where now human is actually informing the agent is updating the task and informing the constituent back, and it is working all behind the scenes, so while the humans are actually performing the real work. I show you a quick demo on this and discard. So another good example is about we spoke about this construction permit. Let me show you construction permit, how it can actually help when we in a construction permit application user flow. So this is a recorded video where we built this agent, which is part of construction application. Whenever you are filling a construction permit app to build a pool in your backyard, to remodel a certain building, and new residential building construction, especially from a real estate company perspective, you get to fill this form where you are defining what type of the property is residential, is commercial. You fill up the application type, ECC code, building occupation, timeline, insurance, contractor, all the information. It's a pretty tedious job, and it takes quite a bit of amount of time to fill this. And then what you realize at the end of the day, that okay, this small safety guideline was missed, or a large or a bigger insurance piece was missing, or something of that sort, then you have to go back and start from the drawing board. But in this case, what is happening, that the agent which is being built already on Microsoft AI Foundry Cloud, it is sitting on top of this application while this permit is being filled in. You will see that once the payment goes through, this agent will perform a preliminary compliance check and already give you a soft approval or soft denial based on what this agent knows, based on the applications, similar applications submitted in past 3 years, 5 years, 10 years of time. So the agent has that data. Agent is collecting the historical information, where agent knows that this type of application typically get approved or typically get denied because there is this variance which is missing in this. So here, as you upload this drawing documents and whatnot, the agent is continuously reviewing it. So it's not kind of waiting for the final submission to happen. So the agent is working behind the scenes to ensure that all the parameters being collected effectively, and then later on putting it into the front of the planning commission and providing all the background details about the similar applications. So here you submit after putting the signatures in. And so this is the final application. You're putting up the building, getting the fire permit, and making sure that everything is aligned the way application needs it. And you pay for the application, and as soon as the payment is complete, it performs the preliminary test. So now if you see here, as soon as you submit it, this goes into in review L1. So while it's in the review L1, the agent is looking into this application, and here agent provide a preliminary check that if this is doable, not doable, or you get the conditional approval. So here, this is something where before even a human logs in, human has this information So now when a planning commissioner goes in, they say that this could be conditional approval, where you have documentation is partially complete, the completeness of compliance analysis breakdown, and you get this information as soon as you log in. So agent is working behind the scenes to ensure that this is complete. And now this compliance check is happening based on the state guidelines as well as the city audiences. So it checks on the real time that what exactly the compliance requirements are for the city or for the state, and based on that it provides you the preliminary check. So this is one of the use case where AI agent could help in terms of building this autonomous platform where human stays in the loop, but at the same time you are making public service delivery more efficient. So where civic agent works. So civic agents are not just part of public service. These agents could work in schools, in hospitals, in utilities, in nonprofits, and perform these type of back office services, which can be then help to elevate the overall efficiency gains in terms of service delivery. Um, so the problem statement which we talked, too many requests, too few people to answer, a lot of email overload, staff burnout, citizens frustration, and which is where you get that okay, I reported this, I'm still here waiting to hear back because the staff is overloaded. How many times we have seen that you submit a request for right to know or OPRA, which is how it is called, or FIOA in United States, where everybody has right to know, and then you submit the request. It takes weeks, months in some cases to get back. But with these civic agents, this entire process can be expedited. Um, in US, National Association of Counties have come up with this roadmap for AI. How these AI, how can we innovate utilizing this AI technology and building this automation roadmap, which is where you could define. So they have very clearly defined in the 6 steps. So building a strategy for management, identifying and conducting the assessments if this is the right use case or not, ensuring that you have the right public and private partnership being established, and that is where the proof of concepts or POCs or pilots are required to ensure that to validate the solution or validate the problem statement that can be utilized from a future solution standpoint, and then moving that pilot phase into production. But while you are implementing it for production, you have to ensure that you measure the impact. That is it something which is going to help us from efficiency gains perspective, or this is more which will reduce the complexity for the entire process, or this is something which provides more authority or auditable capacity to the government. Now, these again for counties, they have defined these 5 use cases or categories for the use cases. That is where you can put, okay, this is government operations and workflow automation, which is where you could ensure that these operating agents or civic agents are being utilized for efficiency gains in the operations. Public service and resident engagement. We saw these 24/7 chatbots. We saw how we can build this chatbot efficiently in Copilot. Simple knowledge-based knowledge agents can be deployed on any web application, and that's how you could improve on the first low-level questions, which can be useful for engagement, and some of these agents can be utilized to have a proactive communication back to the constituents. Emergency resource and planning. I'll show you one quick demo there as well, that how you can build this emergency route or ensure that certain information is being shared. So, for example, this is a quick example for a water leak information, and full transparency. This is the constituent system is built on Salesforce here, and we are building a notification system in this current situation, and this is for a certain block and lot. So there's a water leak happened in the city, and we're going to use GIS capabilities to draw the map where this water leak is happening and notify all the residents who are part of this, who get impacted in this water leak, utilizing this agent. And the agent sits on Microsoft AI Foundry and built out of OpenAI large language model on Foundry, and talks to Salesforce such that the citizen information can be captured from Salesforce. So here we are putting up this critical service area outage request, and this is a message which will go out as a text message to all the constituents who are getting affected due to this. And yeah, so this is currently, this form is being filled by a human so that it can be sent out. And here, this is how we're going to map what all areas or what all block and lot which are getting affected through this outage, and only people living in that in that zone would get notified about the problem. So it, once the coordinates are marked, it will send it for the approval. So this agent is seeking an approval from a human. So we have human in the loop. It's this supervisor will approve it, and once it is approved, this. So these are the people who would be getting email notification or text notification that there is a water leak. So this is another example where we can have a sophisticated agent, very purposeful, doing certain specific thing which is required. Another good example, finance surveillance agent. So this is where you are actually doing a so for demo purpose, I made a CSV driven file which is being utilized, but consider this as a part of your finance application, where while you are putting the records in or adding the line items, treasury is looking into the daily budgets or daily spend, and this agent runs behind the scenes to analyze the transactions. It is not just analyzing the transaction based on your line item, your past expense on that line item, but also ensuring that it is going to a right capital account, or it's getting tagged for the right account, or if there is a certain threshold which has been crossed for the high amount, it will highlight that. If there is a threshold where it says that, okay, this is seems like a rounding off error, so you will get this anomaly error, and that's something which agent can proactively report and submit and fix for you. So here you check that how many differences you get daily report in the email, and based on what you action you perform for this agent, the agent learns, and the next time when you are running this anomaly report, agent will learn that, okay, in past this particular line item was approved. For example, a sheriff car repair cost, and sheriff repair cost for the car repair cost was $100,000, and for last 1 year, and now this time you have spent $10,000, so which is something not matching with the past years, or it could be other way around. Then it could be a typo, it could be a rounding off error. So that's how you make this agent learn, and as time progresses, agent gets better, and then you do not see that as a coming as an anomaly report. So yeah, so based on these categories, we yeah, let me show you another quick one where, yeah, so weak agents shift in public service. So as we talked about, the first and foremost, more of these manual processes, staff shortage, resident frustration for not getting the responses back on time, and this is getting where this whole shift is coming now, where you're getting a faster service, a lot of automation for the back office and internal processes. We talked about DPW, how pothole reporting can be automated. We saw case management, how case management can be done in a better way. We saw how financial reporting can happen better, how we can create these annual financial statements utilizing these agents and the past uh, based on the past data being available, how to build a predictive model around the budgets, not just for small towns or larger cities, but some of these counties and state agencies are also utilizing AI predictive models to build a better um, uh, better routing service, better way of presenting it to citizens, having a faster delivery mechanism. So these are some live examples where you could leverage some of the Gen AI as well as agentic AI capabilities. So let me show you a few more examples here. So in this case, what we are doing is that this is an example from for AI journey for a county, for a local county, how you can identify some of these. So the start would always be identifying the use cases. What are the low hanging fruits? Are these permits which are taking time, or these OPRA requests or right to know requests are taking time? And then picking those use cases, piloting within in a limited capacity, utilizing some of these agents for knowledge agents. Again, as I shared earlier, you can leverage Microsoft Copilot right off the bat and see how these knowledge agents are coming across. So you can do a pilot using those agents, then creating a playbook which helps you define the governance around it, which helps you ensuring the data remains secure. It stays in the sovereign cloud based on which part of the county or agency you are in. If it is something which required from public communication perspective, data is already available out there in public. You may not really want to set up a data security, but still the governance is required. What type of questions being asked and how this AI agent is responding to them, you need to have a solid traceability there. So that is where you could define that. And then expanding it to production, because one agent which is functioning well for your one SOP internally may be you may be able to scale that for your other agencies or other departments. So defining that playbook and ensuring that that goes into production once the playbook is defined could help you build scaling up these agents further for other agencies. Last but not least, the performance, where you can measure and optimize the performance, and not just again from a scalability perspective or how these agents can be utilized on the other departments, but also measuring the ROI on it, and how you are able to save time and get a positive sentiment in constituents. So that being said, there is how this whole civic agent works in this dynamics now. So not general AI. We are not talking about just having a contextual chat. We are not asking a specific question, getting responses back. That is, yes, that is one piece of it. That is one part of the solution. But now you have these autonomous agents which can actually perform a purposeful task for you. Then connecting to your own data sources. You are not connecting to the world wide data. You're not connecting to the world of ChatGPT or Claude, for example. You are having a data source restricted to your own need. So that's where it creates more productivity gains than anything else. And training or based on your forms, your workflows, your policies, describing the guardrails. So these civic agents are not general one size fit all agents. These civic agents are very purposeful built agents which can work right for your government, for your department. And as I was talking about this a framework which NACO has, National Association of Counties, have released. Similar to that, we follow this 5P framework, which is where the first you define the purpose, and in purpose you ensure that why you want to build, what are the use cases, you have to define that, and what is the vision behind working upon these silo use cases. So you have to identify those use cases and what you want to achieve as a part of your AI journey with these specific use cases. Then you build a pilot on that. And this pilot is important because in AI, what we are seeing is that it's uh, it needs to be have a confined scope. It needs to first validate that this is the right purpose for this particular implementation, and if it is the right use case, then yes, I think building a pilot with an AI agent with limited capacity, maybe a one department, maybe having a very specific use case for a specific department, it's important. Third is playbook. So you define the playbook, you ensure that everything is documented, you understand that what are the security guardrails, how the government will happen, is all put together in one place. Then you take it to production. So once the playbook is defined, you take this to production, and while you are deploying in production and you have all the runbook ready for the scalability, it helps you to explore options with other departments. Maybe there is the case management use case we talked about, maybe that is only for pothole, but it could be for construction, it can be for tree removal, it could be for trash pickup. I mean, there is a you could have a variety of these different case management use cases which can go to different departments also. Then performance, because as we have seen in past also, like from a standard software development lifecycle, SDLCs, where you define everything in your development, you deploy it to UAT, you get the UAT sign off, you go to production, and the work is complete. But in the agentic environment now, you once you go to production, that's where the real performance improvement can begin. And you can actually scale up those agentic systems to connect with the underlying applications and provide you much more larger efficiency gains than which you can think of. And that's where, but that can only happen through keeping human in the loop and making sure human is actually leading the effort. And that's where the performance and the monitoring is very important. Big wins, yes. Time saved, that's the biggest win. Errors reduced because a lot of these repetitive tasks require those mundane tasks require that a close adherence to the processes, which is where the reduction of error is important. And you achieve that with this rollout. Transparency improved, everything is getting logged, everything is, each step this agent takes needs to be logged, and leadership gets the right insight what they need, and you have a full traceability of what actions were performed. And employee morale up, and if employee morale up is one thing, and the civic agents also ensure that you get away from the daily grind and the mundane tasks which you do and stay focused on the very human task, and which brings the positive sentiments to constituents as well. So yeah, this is being heard. So any questions, anything? I know we have last 3-4 minutes left now. So that being said, the best time to automate a broken process was yesterday. The second best time is now, and so act today. This is a feedback for my session. If there's any feedback, please feel free to rate me here. And this goes back to Sessionize, and organizers will get the feedback as well. If anyone want to connect with me on LinkedIn, this is my LinkedIn QR code. And yeah, thank you for giving some time today. And yeah, if there are any questions, please let me know. Yeah, happy to answer. We have about a minute left here. Yeah.
Yeah. Wow. Thank you so much, Himanshu. Very, very interesting session. And my question, I don't see any others, so I will ask my question. Do you have a repository where we can find more of your work? Is there a blog outside of LinkedIn? Any link that we can find your work around?
Yeah, sure. Maybe I'll post you my GitHub link, which we are utilizing.
Great.
Yeah, I'll send you that. Yes.
Great. Thank you, Himanshu.
Sure.
This was the best closing for today. Quite an amazing session, I have to say. And yes, we are just stepping into the future, right? And what I liked most of this session is the act. Just act, do, experiment, and then you will find your way. Copilot Studio is one of the leaders, if not the leader, in low code for agents right now. and we're living in the agentic era. So thank you so much, Himanshu, for setting the knowledge a little bit higher, and
Sure.
it's up to us to follow on with this experiment and share the knowledge among us. So this was an amazing session.
Sure.
I don't see any other questions. Again, thank you so much. It was an honor having you with
Sure.
us. Hopefully, we will see
Yep.
you in another session of ours.
Sure.
Have a great one, my friend.
Thank you for understanding. Yep. Thank you so much for
Bye
having
bye.
me. Bye bye, my friend.
Great, great. I'm very happy, I can say, because every speaker had their own personalities, of course, but also their own perspective of how AI operates and how we should operate with our AI, uh, our dear AI implementation, services, applications, and everything around it. It's mostly about automation, as you can see, and not about replacing humans, of course. And there were some challenges that I think most of us, if not all of us, agree, especially in the creative parts. I think humans should stay there. I don't think creativity can be replaced in any way. And talent, of course, talent is something that is not part of an AI or the AI world, but automation and agents working as a team, learning from our instructions and our way of expressing what we need in the context, as we say, can take our applications really really high and make the difference. I hope everyone enjoyed today. If you were from the beginning, kudos to you. 5 hours today. Our first five speakers were amazing. We continue tomorrow with more of our sessions. So visit aiathens.gr, ai-athens.gr, to see our agenda. And let me have just a quick look. We have also the PWA application, which is an application that runs directly on the browser, and you can see there our agenda for every day. You can also pick up your favorite sessions. So if we want to have a quick look here, this is the link. So tomorrow we're going to have another set of five: AI for good, monitoring the mind of AI, rethinking security. One of the important sessions I would really like to watch: building a multi-agent system with a Microsoft Agent Framework and AZD. Yes, this is one of the favorite ones. Empowering Copilot with explainable AI, enhancing transparency and trust. Yes, so everything is on the mix, right? Nothing is missing. Thank you, everyone. Have a great day, night, or afternoon, wherever you are. Hopefully, I will see you tomorrow. Don't be afraid to ask questions. Don't hesitate to ask whatever you want. This is the time to ask. This is the time to experiment, and this is the time to get everything out of our speakers, and of course between us. Uh, Azure AI Connect 2026 day one is over. Thank you, everyone. See you tomorrow. I hope that what I was saying has been heard. Let me replay the video, and if it is not heard or I forgot the mic closed, I will repeat.
Join us for Azure AI Connect, happening virtually from March 2 to March 6, 2026.